is always the same. I'm going to import the tree, then on line 4 of our script we'll create the classifier. At this point it's just an empty box of rules. It doesn't know anything about apples and oranges yet. To train it we'll need a learning algorithm. If a classifier is a box of rules, then you can think of the learning algorithm as the procedure that creates them. It does that by finding patterns in your training data. For example, it might notice oranges tend to weigh more, so it'll create a rule saying that the heavier a fruit is, the more likely it is to be an orange. In scikit, the training algorithm is included in the classifier object, and it's called fit. You can think of fit as being a synonym for find patterns in data. We'll get into the details of how this happens under the hood in a future episode. At this point, we have a trained classifier, so let's take it for a spin and use it to classify a new fruit. The input to the classifier is the features for our new example. Let's say the fruit we want to classify is 150 grams and bumpy. The output will be a 0 if it's an apple or 1 if it's an orange. Before we hit enter and see what the classifier predicts, let's think for a sec. If you had to guess, what would you say the output should be? To figure that out, compare this fruit to our training data. It looks like it's similar to an orange because it's heavy and bumpy. That's what I'd guess anyway, and if we hit enter, it's what our classifier predicts as well. If everything worked for you, then that's it for your first machine learning program. You can create a new classifier for a new problem just by changing the training data. That makes this approach far more reusable than writing new rules for each problem. Now you might be wondering why we described our fruit using a table of features instead of using pictures of the fruit as training data. Well, you can use pictures, and we'll get to that in a future episode, but as you'll see later on, the way we did it here is more general. The neat thing is that programming with machine learning isn't hard, but to get it right, you need to understand a few important concepts. I'll start walking you through those in the next few episodes. Thanks very much for watching, and I'll see you then.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you'll have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless and please, don't join the Bald Club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database writes, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what thread pool executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread pool executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs, but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that RenderScript might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that Systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android Performance Patterns videos, and don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
Hey folks, welcome to Totally Tooling Tips Season 3.
Come check us out. We're going to be talking about progressive web apps, some of the tooling around them.
On first visit, we've got a relatively fast time to first meaningful paint.
Module bundling, accessibility.
Do you know what the top 4 things to look at when it comes to web accessibility are?
No, I can only think of 2. I only think of audio and then visual.
So there's visual, hearing, mobility, and cognition.
The first episode will be out on April the 27th. So subscribe to the YouTube channel, check out Season 1 and 2 before Season 3 starts, which will be happening soon.
We promise that Season 3 is going to be equally as mediocre as Seasons 1 and 2.
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them, and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to this episode of Coffee with a Googler, and if you, like me, love games and love 3D games and all that kind of stuff, then this show should be a treat for you. Because today I'm chatting with Shannon Woods, who's a technical program manager, and she works on our rendering teams at Google, and she's got lots of great stuff to talk about in the 3D space. So welcome, Shannon. How are you?
I'm doing all right. How are you?
Really good. I have to say I'm really envious of your job, but could you tell us what you do?
So I work with a couple of rendering teams here at Google, both Android and Chrome. And we sort of plumb code from user space down to your GPU.
Wow. Can you translate that?
Basically, our job is to get a bunch of triangles from applications down to the GPU as fast as possible.
Cool. And all graphics are ultimately made up of triangles, right?
Basically.
Now, recently you announced Vulkan. Right, and this is this like new and improved 3D rendering API. Could you tell us a bit about it?
Historically, Android and all mobile phones really have used OpenGL ES to communicate to the GPU within the phone to tell it how to draw scenes. But unfortunately, over time, the API has become less and less of a good match for what the hardware is actually doing beneath. So what would happen is you would use this API to communicate a lot of the details about your scene, and the GPU has to reorganize all of that so that it can consume it efficiently and draw it on the screen. So what Vulkan is it's another API from the same open standards group that makes OpenGL. And it's designed to be a lot closer to what the hardware actually does beneath the covers.
Okay.
So if you provide the data via Vulkan, it should be able to draw a lot quicker. Sort of the flip side of that is that, it gives you all of this control, but it means that you have to be pretty good at, making sure that your code is doing exactly what you wanted it to do.
Vulkan and OpenGL ES are both from the same standards body, right?
Yes.
So that's Khronos?
Yes, Khronos.
Khronos, sorry. So you work with the standards body at Khronos?
I do. I get to travel all around the world and see beautiful conference rooms. But it's actually really interesting getting to see how the API is made from the ground up.
Cool.
Android is going to support both OpenGL ES and Vulkan. So developers can choose which API is right for what they're doing. Like if they need to render a FPS game or first-person shooting game that has to run really fast at a high frame rate, then they're going to probably want to choose Vulkan so that they can closely control exactly what's being drawn and when.
Cool.
But if they just want to get a couple of shapes on screen, then OpenGL ES is probably still the right choice for them.
Cool. So it's just really nice to have both.
Yes.
Cool. So, and from my understanding, what you're saying with Vulkan, like just being able to get down to the chipset level effectively allows you to squeeze a lot more performance out of the machine.
Yeah, it does. And one of the other things that it does is that it allows for greater parallelization.
Okay.
There's a lot of work in OpenGL ES that it's blocking work. You make a call into OpenGL ES, into the driver code, and it has to stop and perform the task that you asked it to do, and doesn't return control to the application until it finishes that task. And what this means is that if you have multiple threads, only one of them can really be talking to the driver doing these things at the same time. Vulkan is designed more for multi-threaded applications, so you can have multiple threads doing things like constructing buffers full of commands at the same time.
You're getting onto like programming and skills, and like from a skills perspective, and is the things that developers will need to learn that they don't.
Hello. Welcome, everybody. It's always fun to have mid-afternoon sessions in a hot tent. My name is Sridhar Ramaswamy. I lead the ads and commerce teams at Google. And here with me is Pali Bhatt, the product lead for payments at Google. And we're really excited to be talking to you about all the latest and greatest in Android Pay. I want to start by addressing the elephant in the room. There are tons of pays that are out there. And all of you want to know, who's winning? Is there a winner? But the sad answer is, no, not really. There is no winner. Legacy payment methods like the credit card and cash are still the dominant payment methods that are being used out there. Even the most avid technology enthusiast among us is hesitant or scared to leave our credit cards and cash behind. And the natural question is, what's holding us back? We've thought a lot about this. And we think there are three big reasons for this. The first, of course, is a big one, is that all the mobile payment methods are kind of limited. Some work for physical contactless terminals. Some work with all terminals. Sometimes it works in-app, but not in, but not on the mobile web. And we're going to talk a lot about that. It's the unpredictability of whether your mobile payment method is going to work that makes you want to say, nope, I can't rely on it 100% of the time. We think the second big reason is that a lot of the payment schemes that are out there are kind of uncompelling. We are talking about an activity that all of us do many times a week that we've done the same way for many, many years. And so if you're going to go ask humanity to change the way that they think about payments, like what's the value add? They're kind of uncompelling. And this is something we really do want to address as well. And we actually think that the uncompelling nature of the payment solution comes about because most payment solutions are kind of closed. They have a few key pieces of functionality, and that's it. What makes our smartphones great, whether it's Android or iOS, is not just the operating system. We like aspects of our phones that come directly from Google. But the fact of the matter is, what we really love are our apps. It's a great functionality that comes on. It is the innovation that developers like you have provided on the core platform. There is no comparable thing that's going on in mobile payments. We think that's kind of a big blocker. So what do we want to do? Today, we're going to be talking to you about all the things that we at Android Pay and Google are doing to make mobile payments better for merchants and retailers, for financial institutions, but most of all, for consumers like you and me. We think payments should work everywhere they're expected to work. They should work in a simple and secure way. And we think mobile payments should be more like a mobile payment passport than just a mobile wallet. And what you will hear from us today is our efforts at really making this happen. So we want Android Pay, therefore, to be everywhere where you and I expect it to be present. So we're going to talk a lot about that, starting with how are we going to have Android Pay work on mobile, web. It works fine in mobile apps. We're also going to be talking to you about how I can hear some sound from behind. Can others hear it? So we are also going to be talking to you about how Android Pay can work in other areas, like public transit. We have a nifty demo coming up over there. And also in things like ATMs. Wherever you expect to use payment credentials, we think Android Pay should be usable there. And we'll show you through all of this how we are building a set of consistent and simple experiences that all users will know and love, but one that will also come with the security that is the promise of mobile payments. And finally, we also want to share with you what we are doing to drive innovation in the ecosystem, whether it is with retailers or with financial institutions like banks. Of course, the first part of being everywhere is being geographically everywhere. So we are very pleased to announce the expansion of Android Pay outside the US to an international location, which is we went live in the UK earlier today. Woo! Polly was there last weekend, surreptitiously running transactions with his Android phone, checking things out for himself to make sure that everything was fine. We worked with top partners. You see some of them here, HSBC, Lloyds Bank, to make sure that there is a lot of acceptance for Android Pay. And of course, with lots of apps and lots of physical locations. And this is only the beginning. So I'm also pleased to announce that we'll be launching Android Pay very soon, over the next few months, in Singapore and in Australia. I know our ambition is to be there everywhere Android is. So we're going to be launching in Singapore and Australia soon, with many more countries following soon after. They're all in the works. So we are pleased with how much we will be able to expand Android Pay through the world. Let's switch gears now and talk a little bit about what we've done with Android Pay in-app, inside apps. We launched the Android Pay in-app API in December, and we've been working with a lot of app developers to make Android Pay be accepted within their apps. And we are pleased with the results. Top apps, Uber, Airbnb, Jet.com, Instacart, and many others, some of which are listed here, all support in-app payments with Android Pay. And the first question you're going to ask is like, so what? Does this make a difference? We thought we'd show that with one of the apps that's adopted Android Pay, Fancy. Fancy is a really cool app in which you discover crowd-curated things. This morning I was browsing through stuff. If you can't tell, I drink a lot of coffee. And I found this really neat espresso mug that you could get from Fancy that a lot of other people have liked. Fancy adopted Android Pay in-app and saw some pretty stunning results. For users that use Android Pay within Fancy, they found that their conversion rate was twice that of other payment methods. I don't know how you folks think about conversion rates, but for something like AdWords sign-up, in which a lot of Google's fortune is dependent on, a 1% increase in conversion rate is cause for major celebration. And so getting a 2x increase in conversion rate on what turns out to be a substantial volume, 20% of Fancy's transactions flow through Android Pay, is a big, big deal for Fancy, and is a big, big deal for a lot of the apps that have adopted Android Pay. We are really pleased with the results that we've seen with these and with other apps. I'm now handed over to Polly. He's going to show us a quick demo and also walk us through some of the details of how things are working.
Yeah, thanks, Sridhar. Could we switch to Wolf Vision, please? OK. Awesome. So I'm going to open up my Nexus 5X device. And I want to show you Android Pay working inside one of my favorite apps, Airbnb. I love traveling, and I have a 7-year-old. So we need to make trips to Disneyland very, very frequently, as some of you might know. So I'm going to try and book something for a trip to Disneyland soon. So let's see here. I think I'd saved a search here for Disney. And by the way, this is actually the production app. So I want to make sure that it's actually still available. So let's check for availability. Selecting here, it looks like all of next week is available still, which is very nice. Sridhar, I hope you don't mind this. He's a very good manager. So
the whole week? Who agreed to that?
So let me just save this and try to instant book this. And the cool thing about this is a really beautiful experience, right? the one place where it actually isn't all that great is payments. So if you go in and try to buy something and book a reservation, typically it means you have to try and like type in your credit card details, etc. So we worked with Airbnb to make this much better. So I'm going to try to add a payment. This is where I usually get a screen that says, enter your credit card information, right? And if you have Android Pay set up on your device, you literally have to do nothing else. Just pick Android Pay. That's simple. Shows you the chooser with Android Pay and shows you my Discover card on there already. And all I have to do is confirm with my fingerprint. Okay? And you can see that Android Pay is already selected here. And the next time I come in, I don't even have to do this, right? You automatically can check out, and you're done. So really, really sweet experience. I personally love it. OK, so let me switch back to the presentation, if you don't mind. So whenever I'm presenting with Sridhar, I'm always wondering, where do I stand, right? Because standing here seems like a bad deal. Maybe I should stand here.
There you go.
So what I wanted to share with you is, of course, we've got this amazing integration with Airbnb. We've done the same kind of integration with Uber, all of these top apps, right? But how can every single developer take advantage of Android Pay? We wanted to make it really, really simple. So we worked with a number of top payment processors. I think you can just see this list. It's everybody from Braintree to Stripe to Adyen. We've got CyberSource, everyone integrated into Android Pay. So that adding in Android Pay, if you are a developer, is really, really simple. In fact, if you're an integrator with Braintree or Stripe, literally less than 10 lines of code that you can drop into your Android app and enable Android Pay for your users. So that's very, very awesome. We've also done more. We've opened up our API, the Android Pay in-app API, to all Android developers selling physical goods or services. So you can go to this URL and start integrating right away, regardless of who your payment processor is. So it's very exciting for us. But this is not the whole story with mobile checkouts. To tell us more, I want to hand it back to Sridhar.
Thank you, Pali. It's really cool that in-app payments have been. Did we rush past?
I might have actually just gone right past one thing.
Can I press back on this?
Yeah. Can we go back one slide? Because I just want to show you one more cool thing, which we snuck in at the last minute.
There you go.
And here's the cool part. You must have heard during the keynote earlier this morning about Android Instant Apps. What Android Instant Apps are is this really cool technology that lets you stream an app to your phone. So don't worry about installing anything. You just stream the app by clicking on a link, and you get the full native experience on your device, which is like really awesome. Now, that full native experience wouldn't be as awesome if you had to start typing in all your credit card details to complete your payment. So what we did is work with the Android team to enable Android Pay within Instant Apps. So I'm going to share with you a little bit of this experience. Maybe I'm going to like touch this, and you'll see B&H photo. I do a search for a camera, and you can see that the link literally streams the B&H photo app to my phone. I can pick my camera, check out, and then you get the exact same experience I showed you within an installed app, right? So absolutely cool, and gives you a complete experience right in place, and it's streamed to your phone. There's something that we're very, very excited about, and we expect more and more developers to take advantage of this to reach more users who've chosen not to install your app, but you can still get to them using an instant app, give them the same great experience. The user doesn't have to do anything else. If Android Pay is set up on the device, it'll just work, right? So again, something that we're very, very excited about.
And is the camera going to show up at your place by drone instantly?
that would be actually very cool. But we will talk about how things can show up soon. Here you go. So
Cool.
Sridhar will tell us more about mobile checkouts.
So it's cool that we can solve the problem of in-app checkouts, make it easier, make it streamlined, make it secure. But the fact of the matter is, a lot of us spend a lot of time on mobile web. The time spent skews more towards mobile apps. The fact of the matter is, something like half of all transactions happen on mobile web. But mobile web does not have any of the support that in-apps have had. It's a different programming model. And the result is that you and I are stuck with really long payment forms and really long details forms that we have to fill out very slowly on tiny keyboards. And it doesn't work that well. We give up pretty often. Conversion rates are pretty low. So we took a baby step last year and were stunned by the results that we saw. We did something that we call Chrome Payments Autofill. It's a small idea. Take your Google credentials, your Google payment credentials that you put into Android Pay, that you have put into Google Play, and have it be available for form fill-out on mobile web. Again, for users that actually used payment autofill, for checkout, the merchants saw a 25% increase in conversion rate. Again, a staggering number where wins come in half and quarter and single-digit percentages. And while this is cool, the larger problem still remains. You still have to fill out other details, go through longish checkout forms. Of course, the dreaded user ID and password. I don't know about you, but I have a ton of passwords stored with the password manager on Chrome. I have a spreadsheet full of user IDs and passwords that I have to figure out what to do with. It just keeps growing longer. And we really need to be able to do a whole lot better. So what if I were to tell you that you, as a merchant, will be able to create an experience for your consumer that's going to be simple and secure, using tokenized credentials, and really make these long checkout forms and the crazy drop-offs a thing of the past? And what if you, as a consumer, also were able to see all your mobile web transactions at the same place, along with your in-store and in-app transactions, the way you can do with Android Pay today? We think that would be pretty cool. And so we are thrilled to announce something we call Payment Request, working with the Chrome team and standardizing across all browsers to really simplify mobile checkout. It provides developers and retailers, obviously, the simple tools that they need to create a great mobile payments experience on mobile web. And this way, users have a consistent experience regardless of whether they transact inside an app or on the mobile web. And Polly is going to show us more about how this works.
Awesome. If we can switch to the Wolf Vision again. This is an API we're very excited about because it's an open, standardized API. I'm going to show how it works within a website. So we opened up a website in Chrome, and turns out to be a little store that we built for ourselves so we can order branded gear. And as you can tell, I love wearing branded T-shirts with Android Pay on them, usually.
Always gray?
Always gray, unfortunately, yes. I'm very bland in my taste of color. So I'm going to go in and shop for some T-shirts. As you can tell, we have some cool YouTube T-shirts. We also have just plain Google T-shirts. But because I'm boring, I'm just going to pick Android Pay again. So I'm going to pick an Android Pay T-shirt. I'm going to add it to cart. Okay? And as I add it to cart, this is usually the portion of the experience that you dread when you're on a mobile website. And I've tried checking out before, and it literally is multiple pages of filling out everything from your billing address, shipping address, including your credit card information. Chrome Autofill really helps you with that. But what Payment Request does is help you skip all of this and get that same experience that you saw within apps. So what I'm going to do now is actually show you the checkout experience. So I'm going to hit checkout. Did you notice how quickly that came up? So that's the full native experience showing up in a website with Android Pay just working. Okay? So I'm going to hit pay. And again, I have to confirm with my fingerprint. Okay? And you can see my Bank of America MasterCard there that I'm going to use for my purchase. And it's just that simple. Okay? I'm done. And notice, I also got a notification right away from the store, which I can open up and actually see within my Bank of America app. Okay? Right under the Bank of America card in the Android Pay app, you see all of the transactions that I've made as well. And you see some of the transactions I've made with TFL.
You should notice that Polly did the same thing here that he did for the in-app checkout. He just unlocked the phone, no pins, nothing else. It just works seamlessly, which is what is cool about this vision that we are driving.
Yeah, so it's very exciting for us. But of course, these APIs always require one critical thing for them to be successful, and that's all of you. Right? And we wanted to make sure that we have a set of partners testing this API with us and testing the experience with us so we could really make it magical. So I'm very pleased to announce that we have a really awesome set of partners already signed up to beta test Payment Request, and we also have folks like Shopify and Jet.com adding in Android Pay into this experience as well. So very, very exciting for us. So with that, I'm going to switch gears a little bit, right? And talk about a critical use case for paying with your phone. And this is transit. Transit is something that users in major cities like London do at least twice a day, and sometimes many more times a day. So if there's ever anything that like both meets and exceeds the toothbrush test, if you will, it's transit. Right? So we're very, very excited to showcase the Android Pay experience for transit. And we've done that in partnership with one of the leaders in contactless payments, Transport for London. Okay? Now, if you didn't know, Transport for London completes 13 million journeys daily for Londoners across tube, rail, and bus. So it's absolutely huge volumes. Now, what if you could actually create an experience that was just a little bit faster and more convenient for all of these Londoners taking TFL? And so we want to show you what we worked on with the TFL team. And it's been an incredible partnership. But to demonstrate it, I'm going to direct your attention to the left there to some TFL gates that we've actually got from London. It's absolutely cool. These are the real deal. And what I'm going to demonstrate to you is an experience that has the exact same thing that Londoners are using daily. Right? Now, the only thing we've done here that's a little bit more custom is we've showcased an experience that's going to be rolling out over the next few months. And by the end of the year, we should have it, which shows you a truly amazing experience in terms of how the receipts show up within Android Pay, and I'm going to demonstrate that to you as well. So we're very excited to do this. But without further ado, I'm going to enter in through one station and then exit through the other station. And so you should be able to see me enter in through the Paddington station, I think this is. So Vinny, if you can just focus on the phone here so folks can see it. OK, great. And so I'm going to, no need to open my app, nothing else. Literally, all I need to do, tap, and I've just paid with my Lloyds MasterCard. Absolutely incredible. And I think you saw how fast that experience was. And I personally experienced this when I was in London. So I'm going to tap again. That's simple. And it truly is faster than the experience that you actually can get using other forms of payment. So we're very excited about this. And I'm going to show you the rest of the experience on the Wolf Vision, if we don't mind switching. So the first thing that I'm going to call your attention to is what the receipts show up as. So I'm going to go to my Lloyds Bank MasterCard. Notice that I actually got 2 notifications here, one for entering in the Paddington Station and the other for exiting in Victoria. Okay, really cool. And I'm going to just go into one of those, and it shows you exactly where my journey was. So we're very, very excited to be working with TfL to bring this to Londoners who are using Android Pay. That's the first thing. The second cool feature is today, when you forget to tap out, unfortunately, what has to happen is, and by the way, just to confirm what I mean tap out, as you enter your journey, you have to tap in, as I just demonstrated. But as you exit, you have to usually tap out. Sometimes folks who are in a hurry forget to tap out, and they might get charged the maximum amount for the day. Now, we've solved that problem for both users and for TfL. And you can see that I'd taken a bunch of rides while I was there over the weekend. And I've forgotten to tap out for one of them on purpose. And I got a notification from Android Pay. And I don't know whether you can see it. Oh, it is a little white, so I'm going to try to tilt it a little bit. Can you see that now?
Yep.
Perfect. So I have a notification that reminds me to tap out and complete my journey so I can avoid the maximum fare. It's really awesome for users and really awesome for TfL as well. So very, very excited.
For those of us that have had a Hillary Clinton moment in New York City subways, this is this is a welcome change.
So I've set up Android Pay right when we launched last September. And I've had my Bank of America Visa card in Android Pay. I'm a Bank of America customer. And I've had my Bank of America Visa debit card in Android Pay. I've used it for all kinds of purchases. The one thing I've never been able to do with my Bank of America Visa debit card is get cash at an ATM. But that's changed because we've partnered with Bank of America. And to tell us more is Michelle Moore, the head of digital banking at Bank of America. Michelle?
Thank you. Thank you, Polly. We're really excited to be here today and excited to be a partner with Android Pay. Bank of America is committed to our clients to making their financial lives simple, easy, and secure. And to do just that, we've heard your feedback, and we have built with Android Pay the ability to withdraw cash at an ATM. And you can actually do it live today across 650 ATMs in the Silicon Valley and San Francisco area. By the end of this month, we'll be live at 2,400 ATMs, and by the end of this year, 5,000 ATMs. So why don't we take a walk over to the ATM and see this in action?
Awesome. Look forward to seeing it.
So I figured I would take out $20, and maybe you can buy me one of these Android Pay shirts.
Only cost like $9, Michelle, so we'll send you 2.
We'll have 2. Excellent. Yeah. Thank you. OK. It's as easy as holding the phone next to the reader. It's read the Android Pay. It is asking me for my PIN number, like it normally should for security purposes. So I'll enter in my PIN. $20, you'll buy me 2 T-shirts. Excellent. Good. Just what I always wanted. And here we go. Live now. Here you go. It's that simple. No more reason to carry around your debit card or your credit card.
But Michelle, it's only $16.
You can keep the change.
Well, thank you.
Awesome.
It's a pleasure.
Thank you.
So we're super excited. Thank you for the partnership, and look forward to using this at an ATM really close by. And if you guys are in the San Francisco area for a little bit longer, take advantage of this. Go try it out at a Bank of America ATM near you. Okay?
All right, thank you.
Yeah, thank you, Michelle. Yeah. So you saw a couple of the use cases for using Android Pay, new use cases. You saw, of course, the journey on TFL, and you saw the cash withdrawals at the Bank of America ATM. So now I want to talk to you about one more feature that we're building in partnership with all of our merchants. And that's the ability to save money as well. We already save you time, and it's convenient, but what if we could save you money too? And to do that, what I want to showcase with you is the experience that we've built with Walgreens. It's available to all our merchant partners using an open API again, but we're really thrilled about what we've built with Walgreens. So let me grab one of these phones here, and we can go back to the Wolf Vision. Let me grab both the phones, because I'm going to show you two different experiences, and we are very excited about it. Can we cut to the Wolf Vision, if you don't mind? OK, wonderful. So we have the phone up. And before I actually dive into the demo, I just want to ask you a question. How many of you have signed up for a loyalty card but forgot to use it when you're in the store? It's quite a few of us, right? And so we figured we'd work with Walgreens to help you save the card to Android Pay so we can automatically use it at checkout, so that we can remember it for you and you never have to lose any more points again. Now, there's two ways to do this. The first way, of course, is if I'm an existing member. You remember I told you I had a 7-year-old kid? It means I'm a frequent Walgreens customer. Okay? Go there all the time. And I've signed up for Balance Rewards, which is an amazing loyalty program. And so if you're an existing user like me, Walgreens can just send you an email or an SMS, or even have a button on their site that lets you just save the Balance Rewards card to Android Pay with just one touch. So let me just show it to you within an email. So I've got an email from Walgreens, and they're giving me an offer to save this Balance Reward card to Android Pay, and I'm just going to do that by touching it. And it's that simple. Okay? Balance Rewards card saved to Android Pay. And it's telling you that all I need to do to use this is tap, and I'm set. Okay? Very, very exciting. But then what if you're not a member already? So we decided to build an amazing experience for that as well. So I'm going to show you an experience within Android Pay. Okay? Sorry, let me get this up. Turns out that I've paid at Walgreens, okay, with my Amex card within Android Pay. And I have a receipt from Walgreens already in this app. So open up the receipt. It shows me an amazingly helpful receipt, which has the map, the exact location where I made this purchase, and a personalized message from Walgreens that lets me sign up for the Balance Rewards card. So I'm going to touch sign up here. And notice that all my information is already filled in. Okay? So no typing at all. I'm going to transfer and share this information to Walgreens. Okay? Everything is filled in again. All I have to do is type in a password, which I'm going to do now. Submit. save, and I'm a new Balance Rewards member. So very, very cool. And again, it's as simple as tapping on a Walgreens terminal in order to use this Balance Rewards card. So we've made the experience really, really simple, and it's available to all merchants as well. But let's go in and try to complete this purchase here and show you what the experience looks like. So we have here a terminal. Can we switch to this? Yeah, we have here a terminal. This is an actual Walgreens terminal, okay? And we're going to show you what it's like to make a purchase of one of these really nice like almonds, okay? Turns out it normally costs $5.99. Vinny, can you just focus in a little bit closer on it so that maybe you can actually see the charge? Okay. So I think you noticed it, right? So it's $5.99, except that that's just a regular price. If you have a Balance Rewards card, you get a price break on this, which is very cool, helps you save money. Okay? So what I'm going to do is show you how easy it is to use your Balance Rewards card with Android Pay. So look at my phone. Again, I don't need to open the app. This is the consistent theme. I don't have to open up Android Pay to use it, etc. I'm just going to tap, and I've transferred my Balance Rewards card. That's simple. And I've got a price break, and the new price is $3.99. And to complete this purchase, all I have to do is tap again, transfer my Amex, and the purchase is done. Okay? We're very excited about this experience. So look forward to seeing more merchants integrate to this experience so that you can engage your customers better and your customers get to save money. So with that, I want to hand over to Sridhar.
Thank you, Pali. These are some amazing demos again. Of course, we wanted to make sure that we did something for small and medium-sized merchants as well. So we worked with Square to make available for a limited time to qualified retailers a free contactless reader as well as discounted payment processing on all Android Pay transactions. We want to make sure that all merchants get benefit when consumers use Android Pay to pay. I want to touch on something really, really important. It's the last portion of our talk, but it's super critical. It hits many of the points that I talked about earlier. It's clear that financial institutions, the ones that we have our credit, debit, all these relationships with, need to play an active role in moving the mobile payment ecosystem forward. And when we envisioned Android Pay, we created APIs that these banks could use to bring the payment experience right within their app. Why is this a big deal? Because there's a lot of detail to implementing a great payments experience. And they could integrate it right into their app, saving themselves a lot of implementation headaches, security headaches, and of course time, which is the most important currency. And they do that, then they're free to innovate on what else they offer their consumers. These banks are often the ones that know us best. They're the ones that are observing our transactions. They're the ones that we have our relationships with. We think this will drive a lot of innovation in how mobile payments are brought out to consumers. So we're very pleased that a number of banks, both in the US and abroad, are working with us to integrate Android Pay directly into their app. We think this will drive more innovation and provide more flexibility for consumers. We think of this as a win-win for Android Pay, and for these banks, and of course consumers as well. And with that, now I want to thank all of you our developer partners, in bringing this Android story forward. Without us working together, there's not going to be a lot of innovation. And so we really look to working with you to improve the way mobile payments work. So, and for us to get past the which pay is doing what and more to mobile payments just work in a way that is expected and convenient for all of us. So thanks to all of you for helping us realize this vision of Android Pay being everywhere, in mobile apps, in physical stores, in mobile web as well. So Polly and I have barely touched on the surface of topics that can literally take days of discussion. We're going to be having lots of breakout sessions over the next 2 days, and I think one right after this session,
right after this.
right here.
Yeah.
And so please attend those. Please ask us lots of questions. There'll be folks from the payments team in all of these breakout sessions. We look forward to talking with you and really helping bring this vision of Android Pay to the larger world. And with that, thank you all for coming.
Thank you.
To get better, and
Yeah.
you should tap into them. I think a lot of times we think, I hear developers say, "There's a really bad review. Can you make it go away?" And I'm like, "No, harness it. Your user really cares. So what can you do about it?" But they're also telling you positive things. So on Google Play, one of the things we've really focused on is to how to get developers harness all the intelligence of the users to make better products. So everything from alpha beta testing to stage rollouts, and now we just introduce A/B testing, which we call store listing experiments. So harnessing the intelligence of your users, who are your biggest advocates, and your users to make apps better, I think is something people don't use enough.
Well, and we just mentioned an article on the show about ratings and reviews in the Google Play Developer Console. And I think we've done a lot of work there to bring that intelligence into a format that's actionable and really intelligible at the same time.
Absolutely. One of the big things developers told us is that we love the fact that we can reply to reviews and that we can have a direct channel of communication to our users. However, there are so many reviews. How do I find the themes? How do I know areas that I should focus on? And what I find interesting is that there are folks who view it as something as a problem to fix, but a lot of people are now looking at as strengths that they need to leverage. So they're looking at it as a way to measure community sentiment management. So what we did is to say, how do we measure sentiment? And the tools that you're talking about allow developers to, use Google Smarts to understand all the hidden gems in your ratings and reviews.
That's cool. Developers often ask me, and I'm sure they ask you as well, what's the secret? And coolest thing is you actually recently published the second version of the Secrets to App Success on Google Play, which you should check out and will be linked in the show notes. However, maybe you could give us a highlight. What's one of your favorite kind of insights from that book?
The first thing we did was actually put it out linearly. So the nice thing about the book is that you can always just jump in where you are at the stage of what matters to you. So if you're in design, there is a section for design. If you're in place where you're building growth, there's a section for growth. If you're thinking about, should I use ads for monetizing, there's a section for that. It goes not just about Android and Play, but also looks at other Google technologies, like ads, for example. So that's a huge plus. So the big insight I would like to point there is to really think about this, what it means to be not constrained by the market that you're in. Android is huge.
Yeah.
It's around the world.
Okay.
And you could be a global business no matter where you are. This book gives you interesting ways to tie from everything from how do you design for various markets, how do you localize, but also how you price. So that I think is...
It's really inspiring.
Yes. I mean, think about it. 20 years ago, they would have needed a new management team to figure out how to take a business global.
Yeah.
Now you could do it from your living room.
And sales offices in multiple markets, whereas, again,
you can.
That's great. Thanks for joining me today.
Thanks for having me, Timothy. This was fun.
For more information about everything that we talked about, check the show notes for links. And of course, subscribe to this channel for more interviews like this. I'm Timothy Jordan, and I'll see you next time.
Polycast 43, take one.
Hey there, Polycasters. Rob here. Welcome back to the show. Last week, we were doing this thing called Ask Polymer, where we take questions from you and then we try and answer them here on the YouTube channel. And as we were collecting those questions, I noticed a lot of folks were asking, when's the Polymer team going to create a data table? Or what is the roadmap for this particular element and stuff like that. And as we were going through that process, I really started to think that, if web components are going to be successful, we're going to have to scale beyond the Polymer team. Really, it's going to be up to all of us out here in the community to start making cool stuff, sharing it with one another, and also promoting it, right? So one of the things that I wanted to do was, here on this show, I want to start a new segment called Built with Polymer, where I take all the cool stuff that you're building and we just show it off so other folks can get involved with the projects and start using it in their own applications. Now, to do this, we're going to start off by looking at a website called customelements.io. I'm curious, show of hands, how many of you have seen customelements.io before? OK, I noticed that you did not raise your hand, sir. So for you and for other folks like you, I want to just walk you through how this website works and some of the cool stuff that's on there. So if you haven't seen it before, customelements.io is pretty badass. You can think of it kind of like NPM for web components. It's sort of a registry. It collects all the things that are actually in the Bower registry, and then it displays little bits of info about it. So you can search and you can find the different components that are out there. You go to the website, and the first thing that you're going to see up here are these three sort of main sections. You've got the stuff that is recently created. It's brand new. You got the things that have been recently updated, which I always like to see. That's supposed to be a clock. And then you've also got the stuff that's the most popular elements out there. So the things with the most GitHub stars. All three of these very useful categories to kind of keep tabs on. And one of the things that I also really like is you've got this really huge search field up at the top. Anything that you could kind of imagine needing a component for, you can just go type. So I might say, oh, I want something like a table. So go type in table, and now I've got all of these cool results popping up here for various kinds of tables. Another thing that customelements.io gives you, which is pretty awesome, is at any point if you want, you can click on someone's profile photo. And this will show you not only their profile page, but also all the cool elements that they've produced in addition to that one that you were looking at. So if you think someone's making some really high quality stuff, you can kind of stalk them on customelements.io and see what else they're making. Going back to where we were last week, a lot of folks were asking, when is the Polymer team going to create a date picker in the material design style? Now, this is something that is not currently on the Polymer team's to-do list. We have a lot of elements that we've created, and right now what we really want to focus on is sort of polishing those, closing bugs, and making sure that they work really well. So at the moment, no one is actively working on a paper date picker, and that, for a lot of folks, is sort of a dilemma. But if we go to customelements.io, we go to the search field, we can just type in date picker, or just date, whatever, and we can see right here, right away, we've got this paper date picker that shows up by this guy named Ben Davis. So let's scope that out. And looking at the component page on customelements.io, we get a lot of information really quick right here. So I can see, for instance, how many stars this component has. I can see how many people have forked it and how many people are watching the issues on it. I also get the one-liner to install this on Bower. And what I think is maybe one of the most important aspects of the site, I get this activity panel here. And on the activity panel, I can see that the component was created a year ago. And most importantly, I can see that it was last updated 11 days ago, which tells me that this is still being actively developed. People are contributing to this thing. They're patching it. They're fixing bugs. And it's getting a lot of love right now, which is important for anything that I'm going to add to my application. Also, we've got the list of Bower dependencies down here on the right-hand side. And again, it's really valuable because I want to know that, hey, is this thing depending on the latest version of Polymer, or at least Polymer 1.0 and some version above that? I don't want an element that is Polymer 0.5 or Polymer 0.3 or anything. That's just not going to work in my app. So having all of this information just kind of at your disposal every time you go check out one of these elements is a huge, huge benefit, and one of the main reasons why I think everyone should be using Custom Elements IO. Now, the other thing that it does is it slurps in the README for this element. So you can see here on the left, I've got kind of the GitHub README that's just been pulled into the website. And if you want, you can go down here and click on the component page. And this is going to give you sort of the classic Polymer docs style, right? You've probably seen these before, where you can see properties that an element supports. You can see the methods that it supports as well. One of the things that I noticed was not showing up here, usually up in the top right corner, there's a little demo button. It's not showing up on this page, but we can just add that by typing demo into the URL bar. And now, we've got our paper date picker showing up. And you can see this thing looks pretty nice, right? I can go click around different dates. Changing the month gives me these sort of cool material design ripple effects. Close it, and then I can click this button again to show you how it reopens. Lastly, one of the things that's really important is making sure that the date picker is responsive. So I go grab the corner of my browser, start shrinking the page, and then boom, you can see that it has changed its layout, which is really, really good for mobile devices. So that is just one element that Ben Davis has produced. If you go back to his profile on customelements.io, you can see that he's got a few other items here. Paper chip, paper time picker, slightly different from a date picker, paper full screen dialog, a lot of really interesting looking stuff there that hopefully we can show off in a future episode. So go find some elements on customelements.io, go find the authors, stock them on GitHub, don't stock them in real life, but stock them on GitHub and on this website, right? So you can keep tabs on all the cool stuff that they're building. Another thing that happened last week was a lot of folks were asking, when's the Polymer team going to create a data table, something that is really sophisticated that I can filter, where I can rearrange columns and do all sorts of stuff like that. Honestly, again, this is one of those things that it's such a big undertaking. No one on the Polymer team currently has it on their to-do list, because building a complex data table, you could seriously just found a company just on making a killer data table. And in fact, there's a group of folks who have done just that. So recently, a team called Vaadin released a set of elements, which they're calling Vaadin elements. And very similar to the product lines that the Polymer team vends, things like iron elements and paper elements, they put out this set. And the Vaadin elements are split into kind of two categories. You've got these business-oriented elements for things like data tables and combo boxes. They've even created an icon set of kind of businessy icons. And then they've also got a bunch of sort of data visualization components, Vaadin charts. Now, the core elements, as they call them, these sort of business layout ones, these are all free and open source. They are Apache licensed, so you can use them in your project today. And then the chart elements, those are a commercial license, which you have to pay for. But since a lot of you were asking about data tables, I thought this would be a really good one to highlight because it's available on GitHub and you can mess around with it and use it today in your project for free. So if you go to their website, which is at vaadin.com/elements, they've got this little demo button. And if we click that, it's going to show us this cool expense manager application. So I'm going to scope out the live demo for this puppy. And we've got a really, really nice looking experience here. So kind of classic table layout, columns and headers. What I really like about this is there's these filters up at the top. So I can just go and check some of these values. And for instance, checking in progress and reimbursed, you can see over here the amount of items in the table is changing as I'm changing these values, right? You can sort of see them changing over here as well on the left. We can also look for different merchants. So I could say, oh, I just want to see stuff from the taxi merchant, for instance, and we'll just get only the expenses related to that category. Likewise, we can search by min and max values. A lot of cool things you can do here. They've even got this little floating action button down here at the bottom. So you can use that to open a dialog and actually add a new expense to this table. Really, really cool example. Really, really cool, powerful element. It's one of those things that, again, it's not on the Polymer team's agenda at the moment to build, but here you've got this awesome community-built project, which we can all start using in our own work. So yeah, that about covers it for today. I know I've only shown a couple elements, but there's actually a big, long list of elements that I want to start featuring on this show. But before I get into that, if you out there, if you've got some stuff that you've built which you would like for us to show off, it can be elements, it could just be cool projects that you've built, please leave me a comment down there in the YouTube comments, or you can ping me on Twitter at #BuiltWithPolymer. That about covers it for today. So as always, thank you so much for watching, and I'll see you next time. Ready? Yeah.
43, take 2, second sticks.
Hey there, Polycasters, Rob here. I'm gonna pause for a second. Oh, Twitter notifications.
If a tree falls in the forest and nobody's there to hear it, does it make a sound? More importantly, if your app gets published to the world and nobody's there to download it, was all that work for nothing? These aren't just philosophical questions. Discovery is a major issue for everybody. It doesn't matter if you're a two-person shop or a big corporation. And while there are many avenues for potential customers to discover your app, one of the most common is through recommendations from friends and family. Developers know this, which is why you see referral codes like this in a lot of apps. It's a good way of enticing users to share the app with their friends. But while these kinds of referral codes can be effective, they're also kind of a pain to use. Is your user really going to take the time and effort to copy and paste a referral code into an email, send it off to their friends, hope those friends then find and install the app, dig up whatever code redemption screen they need to redeem this offer, and copy and paste this code back into your app? Well, maybe, but maybe not. And while you could build your own UI to help this process along with, all those spare engineering cycles you've just got lying around, this is also where Firebase Invites can help. Firebase Invites makes it easy for your users to share all aspects of your app, be it a referral code or an interesting piece of content, across both Android and iOS. It looks something like this. Let's say that your app has a referral code that you'd like your users to share with their friends, and you decide to use Firebase Invites to make it happen. When your user clicks that share button, they'll see a dialog listing all their friends and colleagues with some smart recommendations at the top. They choose which friends to share with, click send, and these invitations are sent, along with a personal message, over SMS or email, depending on the contact. Their friends receive a customized, richly formatted invitation, either one you've designed yourself or one you've let Firebase Invites build automatically from your app's store listing. All this recipient needs to do is click on the call to action button, and Firebase Invites will take them directly to the app if they already have it, or the appropriate app store for their device if they don't. Once they're done installing your app, Firebase Invites can then send the referral code to your app through a deep link. And you can send your new customer the discount that they so richly deserve. And yes, this really does work even if that friend had to install the app first. Traditionally, deep links tend to get lost during app installs, but Invites uses Firebase dynamic links, which are able to survive the App Store installation process. As an added bonus, many developers have found that not only are these kind of invites more successful at driving installs, but that users who join through this kind of personalized onboarding flow are more likely to come back to your app in the future. And Firebase Invites isn't just for referral codes. You can use it to share any content you want from your app. Have a recipe app? Firebase Invites can make sure that killer lemon meringue pie recipe gets the visibility that it deserves. And because Invites is a Firebase product, it works with Firebase Analytics to let you know when a user has opened or installed an app through an invite. So be sure to check out the documentation and give Firebase Invites a try.
Hello, everyone, and welcome to Behind the Scenes What's New in Android Accessibility. My name is Maya Ben-Ari. I'm a product manager on Android Accessibility, and with me today are a couple of people from the accessibility team. We're going to show you a couple of new features, a couple of new demos, and a unique look of behind the scene. So this is our agenda for today. We'll give a brief overview about accessibility. We'll talk about what's new in accessibility in Android N. We'll talk about the Gesture Dispatch API and show a couple of very cool demos. Also, we'll look through voice access, a new service, a new accessibility service, and then we'll give a brief look of behind the scene in UX research. So let's start. What is accessibility? Accessibility is about creating products that are usable by everyone, including people with disabilities, such as motor impairment or visual impairment. But I'd like to rephrase this definition as slightly different. And I would say that accessibility is about challenging the assumptions we make about our users. For example, can the user see the device or distinguish between colors? Can he or she touch the device or hear back the sound that the device is producing? And can the user speak back to the device? Now, this is not a small number. 20% of the US population will have some sort of a disability during their lifetime, according to the US Census. But it's not only that. Challenging the assumption can benefit all the users. Why? Because some of the technologies that were developed in the past, such as speech recognition or word prediction, started as technologies for users with accessibility needs. But this is not all. We are all accessibility users sometime. This is called situational disability. When we drive our car, we cannot look at our phone. When we are in a noisy environment, we cannot hear the sound of the device and we cannot speak back to the device. And when we carry heavy bags from the supermarket, we cannot touch the device. So we want to design an inclusive experience for all users, regardless of what restriction the user might have. Now, let me briefly mention some of accessibility services and features available on the platform today. So first, what is an accessibility service? This is a long-running privilege service that changed the interaction model with the device in one of two ways. One, it can change the way the user interacts with the device, or it can change the way that content is presented to the user. Now, the first accessibility service we have on the device today is TalkBack. TalkBack is targeted for people with vision impairment or blind, and it's basically a screen reader. Now, the user can interact with the device using touch gesture, and content is presented, and content is spoken to the user through text-to-speech. The second accessibility service is BrailleBack. So can we switch to the demo? So BrailleBack is similar to TalkBack, just in this case, the user can interact with something which is called a Braille refreshable display. The user can type through these keys or interact with this joystick, and then the content is presented using Braille in those Braille cells with the dots raising and lowering. The next service is Switch Access. Switch Access is targeted for motor-impaired users who have trouble interacting with the touch display. In this case, we have something which is called Adaptive Switch. This Adaptive Switch has two buttons, and the user can configure one button as Next and one button as Select. And using only these two buttons, the user can interact with the device. Note that the switch can be with more or less buttons. Can we switch back to the slides? And the last accessibility service is Voice Access. In Voice Access, the user can perform low-level interaction on the device using only his voice. This is a new service that we recently launched, and Patrick and Scott from the accessibility group will soon tell us more about this one. We also have a couple of accessibility features already baked into the platform. For example, large text, magnification gestures, color inversion or color correction for people with light sensitivity or who are colorblind, high contrast tests, and caption support. In the next section, we're going to dive into the latest and greatest feature for accessibility in Android, and we had a lot of very exciting things to share with you. The first one is vision setting on the welcome screen. This will enable visual impaired users to independently set up their device. Now, can we switch, please, to the demo? Focus. OK. So this is the main screen, the welcome screen on Android. And here at the bottom, we have vision settings that flashes every 10 seconds. Or 3. Here you go. So if I tap on that, I'm presented a couple of options. I have magnification gesture, font size, display size, talkback. So for example, I can select magnification gesture, and then I can triple tap, and I can increase the size and magnify the UI. Now, another option that I want to highlight is display size. This is a new feature launched in Android N. So if this is the regular screen size, I can increase the size of the overall UI to be bigger. Now, the nice thing about all those settings that whatever settings I'm selecting, it's going to be reflected both through all the welcome screen, but also as the user setting throughout the device. Back to the slides. Another cool feature is mono audio support. This one is intended for people who have a hearing loss in one ear. And this enables them to listen to mono audio stream. And we do that by combining the left and right channel into a single mono audio stream. And we also have a couple of new features in TalkBack, including improved tutorial clarity, improved gesture detection to work better across different devices and hardware. And also, we added a new API for accessibility service to turn themselves off. So if the user accidentally turn on TalkBack on the welcome screen, it can easily turn it off. Now, the next section is about the Gesture Dispatch API. And this is something that I'm personally very excited about it, because now we will allow app developers to build services such as point scanning, face tracker, and eye tracker. So for the next one, I'd like to invite Anna, an engineer on the accessibility team, to demo the APIs.
Thanks, Maya. I'm Anna, and I'll tell you about the new Gesture Dispatch API that lets accessibility services mimic touching the screen. First of all, what's a touch? Well, it has 3 parts: placing a finger on the screen, drawing a path or gesture, and lifting the finger. The new API lets you, as the developer, specify that middle portion, the path taken by an imaginary finger or fingers. Now, why is this important for accessibility? Let's take a look at Switch Access, an accessibility service that does not assume that you can touch the screen. Rather, it lets you use a switch or a set of switches to move highlight across actionable views and select the currently highlighted view. Now, this leaves off some functionality when you don't want to interact with the entire view, but rather a small part of it. The example that I'll be using is Google Maps, specifically the Maps area, which supports complex gestures, things like zooming in and out and panning the visible area. So with this new Gesture Dispatch API, we can add point scanning to Switch Access, and that lets us perform these complex gestures. So let's take a look at how we can use one switch to operate Google Maps. we'll start in the Maps app, and you'll notice here I have a switch already connected to my device. I like to get walking directions to the 3 buildings just west of here. I don't quite remember what they're called, but fortunately, once we make a selection on the map, we can get directions that way. So here, it seems like I don't see those 3 buildings on the map, so I'll have to pan to get to see them. I'll start point scanning by pressing the switch, and the first thing I'll do now is select where I want to perform that gesture. First the Y coordinate, then the X coordinate, and here I'll choose to swipe right. So now in the lower left, we see the 3 buildings that I'd like to walk to. I'm going to place a pin there by long pressing. So again, I'll start by choosing the location first, starting with the Y coordinate again, and then the X coordinate. And here I'll choose long press from the Actions menu. This gives me a button at the bottom of the screen asking whether I'd like walking directions. As that's exactly what I'll want, I'm going to select that button. So again, I'll choose the location first, and here I'll choose Select. And here we are, directions to the point we just chose from the map using just one switch. I'll hand the mic back to Maya now, who will tell you about another really cool application of the Gesture Dispatch API.
Thank you, Anna, for the demo. And the next demo is an extremely exciting one for a head tracker using the Dispatch Gesture API by a company called Sesame Enable. Sesame Enable is an Israeli company that was co-founded by 2 people, Oded, who is a computer vision expert, and Giora, who is an high current engineer who became quadriplegic due to spinal cord injury. Now, Sesame Enable utilizes the front camera of the device to track head movements and move a mouse cursor. Now, I'd like to invite Vladi, the head of development from Sesame Enable, onto the stage to demo the technology. Hey, Vladi, how are you doing?
Great.
Ready for this? So the first thing that Vladi will do is he will, can we move to the demo? The first thing that Vladi will do is enable the service. Now, this can be done through voice, but because of the acoustic here, Vladi will just tap on the Sesame Enable notification. Now, the service will calibrate Vladi's face. After it locks it down, Vladi can control a mouse cursor using only his head. Now, if Vladi would like to tap on something, he just dwell. And he can tap. Now, once Vladi is into his email, he can swipe up or down. I think we're a little bit excited. Shaking. It's okay. It's okay. Would you like me to help you? Do you want me to help you?
You can try.
Let's try it out. So the first thing that I'm going to do, and we didn't rehearse it, so I'm going to try to help here. I'm going to calibrate my face. Okay, now I can control the mouse cursor. It's a little bit hard here because the overall stage is shaky. It is hard. Yeah, it's hard to calibrate. The overall stage is shaky and it's hard to do. But this is what this demo is all about. So in general, after we move the mouse cursor, we can also lock the sensor. This is by looking right. Yeah. Yeah, sure, try again. Just go to Candy Crush. Yeah, sorry. So in general, this demo is about how to control a mouse cursor using the device. It's a little bit hard to do it on stage because the whole stage is a little bit shaky. Let's try it. And so the thing is basically you can do everything using a hand tracker on the device, including tapping and touching and swiping, and also downloading any app from the Play Store and basically interacting with that app only using your face. So if you want to try it out in a little bit of a less shaky stage, you are more than welcome to come out to Access and Empathy Sandbox to try it out. And one last note about this API, that while this API is very powerful, it doesn't diminish the need for app developer to make their app accessible, such as adding content labeling or increasing touch target size. Because while the API allows you to interact with different elements on the screen, it doesn't know which element it interacts with. So following Android best practices is still very important. So thank you so much, Vladi, for your help. And with that, I would like to hand it off to Patrick and Scott to talk about voice access.
Is there a clicker? Hey, where's the clicker? Oh, here it is. Grab this. Okay. Alrighty. Thanks, Maya. I'm Patrick Clary, Product Manager on Accessibility at Google, and with me is Scott Newman, Software Engineer on Accessibility at Google. And we're here very excited to talk to you about a new accessibility service for Android called Voice Access. And this is an accessibility service that is meant for users with a motor impairment that find it hard to use a touchscreen with their hands. But before I want to talk about that, I want to tell you about one of our testers, whose name is Andy. Andy is a 65-year-old male with essential tremor. And for Andy, he really likes to be able to communicate with friends and family and send them pictures through email and messages and updates. And he generally does this at home on his desktop PC, utilizing an app like Dragon Naturally Speaking, which allows him to dictate by voice. However, Andy would really like to be able to do this on the go from his mobile device. But due to his tremor, using a touch screen is very problematic. Now, if we take a step back here, we realize that Andy's experience is not that unique. In fact, there are millions of people in the US alone that have some form of motor impairment that impacts how you can use a touch screen. So this can range from people with essential tremor, like Andy, to people who have Parkinson's, amputees, people with arthritis, even people with spinal cord injuries, just to name a few. Now, in addition to that, there's many more people who have what we call a situational disability, like Maya mentioned before. This could be a temporary impairment that affects their use of a touchscreen, something like a broken hand or wrist, or maybe their hands are occupied. A common use case we actually hear is that someone might be cooking and their hands are dirty, they don't want to use their hands, and they'd love to be able to still control their device. So this is really the motivation we have for voice access. And our goal with voice access is to provide someone this complete control of their device through use of their voice alone. In essence, we want to be able to allow users to click by voice. Or to put in the words of one of our testers, use your voice and you're able to access the world. So you might be asking, how does an accessibility service like Voice Access differ from a voice assistant, like Google Now or OK Google, where you can say this hot word and then perform a search query, which is more conversational, or you can perform a voice action, like you can set a reminder, you can create a calendar event. An accessibility service is different. What we're looking for is to empower people to be able to use their device and have full device control. Now, the high-level voice assistant is really lacking the fine-grained commands needed to do this. So for example, I mentioned Jeff likes to send messages to friends and family. So from his mobile device, if he wanted to do this, he might have to open the camera app, take a photo by pressing a button, then open an app like Hangouts by clicking on the icon, scrolling and swiping to the contact he wanted, clicking on attach the photo, and then tapping on the text box, typing in text, and then clicking send. So with voice access, our goal is for each of those touch actions to enable a corresponding voice command that allows users to chain together a series of these commands to perform a complex task. So to see it in real life, I'll hand it over to Scott, who will give you guys a demo.
Thanks a lot, Patrick. So my name is Scott Newman. I'm a software engineer on the accessibility team, and I'm excited to give you a demo of voice access today. Before I go ahead and get started, I just wanted to mention that, as some of you may be aware, speech recognition demos can be fickle in front of live audiences. So if you run into any issues, just bear with me and we'll get through them. So with that, let's go ahead and get started. So I remember that Patrick sent me a message a little bit earlier, and I'd like to read it. But before I actually read the message, I'm going to go into accessibility settings and enable large text, so it's a little easier for those people in the back of the room to see what's on the screen. Open Settings. Scroll to the bottom. Tap Accessibility. Tap Large Text. Go Home. Go Home. Let's try one more time. Go Home. All right, there we go. So that's voice access in action. So what actually happened right there? So you may notice that there's this persistent blue button that appears on the top right of the screen. And so that's a voice access activation button. So from any screen, you just press that button, and then voice access starts listening. And then from there, you can issue commands to globally navigate the device, interact with individual elements on the screen, and basically control your device entirely by voice. So what I did there was I opened the Settings app by saying Open Settings. I said scroll to the bottom to actually scroll the screen down as if I were performing a traditional tap gesture. Then I said tap Accessibility to tap the corresponding button on the screen that was labeled with the text Accessibility. And then I did the exact same thing to press the switch labeled Large Text. So this actually uses the same accessibility APIs that underlie the other accessibility services that we've seen so far, like TalkBack or Switch Access. So as long as you follow accessibility development best practices, your app should actually work with voice access right out of the box. So with that, let's actually see the message that Patrick sent me. Can we go back to the cast? Thanks. Open Hangouts. Patrick Clary. Stop voice access. Again, so I used voice access to open the Hangouts app, and then when I said Patrick Clary, it actually found the clickable button on the screen with text that was labeled Patrick Clary, and then clicked that button on my behalf. So one other thing that you may be noticing is that there are these numbers that are drawn on the screen whenever voice access is actively listening. And so what that is kind of a safety fallback. So if you want to interact with something on the screen that's clickable or scrollable, and there's no text associated with it, let's say a clickable image, then you can default to just saying the number, and it will click that element on your behalf. So with that, I'm going to respond to Patrick's message and then send it. Type, the party is at 7. I actually noticed that I made a mistake. The party is, I think, at 8 instead of 7, so let me change that really quickly. Replace 7 with 8. So in addition to navigation, interacting with individual elements on the screen, we actually offer a full suite of text editing commands. And so that was just one of very many that you can use to edit text. You can replace parts of text with other text. You can copy. You can move elements around. So just a really fast way to actually interact with whatever's on the current screen. And the Hangouts app actually didn't need to do anything special to work with voice access. It just works right out of the box. So what I'm going to do now is send the message. You'll notice that at the bottom right of the screen is this green send button, and there's no text associated with it. So in order to click that button, I'm going to reactivate voice access, and then I'm going to say the number that's associated with it that appears right next to the button. Then it's going to click that button and send the message. So let's go ahead and do that. Tap 11. Stop voice access. Undo. Stop voice access. So that's voice access for you. So notice that you can start voice access by pressing this blue button. Actually, if you want to do it completely hands-free, if you say the OK Google command, there's actually another way that you can access it completely hands-free by voice. We offer a whole host of activation methods, so you can choose what's most efficient for you. Similarly, you can stop voice access by saying stop voice access, or just by touching the screen, which is kind of a fail-safe option to leave voice access quickly. So that's voice access in practice. Can we go back to the deck, please? Thanks. So let's hear from some actual voice access users about how it's impacted their lives. Roll the video, please.
Let's go, guys. My name's Stephanie, and I just finished my master's in advertising. I'm a C4, C5 split level quadriplegic. I have no feeling from my collarbone down, so it is absolutely vital that I'm able to use my voice. Okay, Google, start voice access.
My name's Jeff, and I have a neurological condition called essential tremor. It is incredibly difficult to use my hands and fingers. It is very easy for me to use my voice. Okay, Google, start voice access.
After using this product for probably about 10 seconds, I think I'm falling in love with it. Open camera. You use your voice, and you're able to access the world. Shutter. Share. Hangouts. Astrid Weber. Send.
I cannot tell you how excited I am about this product. Open calendar. new when you don't have the ability to use your fingers and hands. Family movie night. It's really all about voice.
So that's Voice Access. We're really excited for you to try it out. It's in open beta right now. So if you come over to the Access and Empathy sandbox area, you could try it out yourself. With that, I'm going to hand it over to Astrid and Jin, who are going to talk about how you can use UX research to improve the quality of your product with Voice Access as a case study. Thanks a lot.
Thank you, Scott. Hi, my name is Jen, and this is Astrid. We are inclusive design and researchers in Google, and we wanted to share with you today a little bit about how UX research influenced and drove the design of Voice Access. But first, what is UX research? The general definition is that it focuses on understanding user behaviors, needs, motivations through observation techniques, task analysis, and other methodologies. The key here is that why we might think we know what users want because maybe we are users of our own product, or maybe we are really close to it and develop it and design it, it's critical to get out there and get feedback from external users and understand their unique perspectives, insights, challenges, and pain points. In fact, the products that we demoed here today all underwent many iterations of design and development, and all of which were inspired and driven by UX research. The process itself is about a 5-step process, and it can be cyclical if you want to keep refining. The way it was applied to Voice Access, it was first looking at what are the objectives of the product as a whole. One key objective of Voice Access was that they wanted to ensure it was easy to use, easy to learn how to use right out of the box in a hands-free manner. And so from there, they developed hypotheses. Okay, so based on that objective, they thought that contextual help was the best way to allow people to learn how to use the product in the moment. From there, they defined what the best methodologies were to use, conducted the research, synthesized those findings, and reported those back to the team, which further iterated on the design of the product. So now Astrid's going to take you through the specific methodologies used and how those insights actually impacted the design of Voice Access.
Thank you, Jen. I'm Astrid Weber. I'm a UX researcher working on Voice Access, and I'd like to show you how we accompanied the design and development process with a few research methodologies. And I'd like to get started with formative research. Formative research is if you go into the field in order to understand about your users from their daily lives. So you go and see how they work, how they live their lives at home. And we did that in particular with users with severe motor impairments, as you've seen before with the user in our video. What we learned out there is that at the moment, there is no cohesive strategy for people who cannot use their hands in order to access their mobile devices completely hands-free. After we knew that, we went back and developed the first prototype of Voice Access. As soon as we had something that was testable, we did test it. And we did so with internal testing. Internal testing is probably best known to tech companies because all you need is yourself. So all of us within the team installed the application, people outside the team, and we tried to use it in as many circumstances and contexts as possible. What we found was a lot of bugs. So we addressed those bugs, we made the product better, we iterated it, until we got to the point that we felt the product is so stable now that we can actually put it in front of real users. And that's what we did. We ran usability studies. Usability studies are when you invite people to actually come into your lab. Those are people from the core audience, so in our case, people with severe motor impairments, and they test it. And you are in front of them, you can see exactly what they're doing, and they're running through a couple of tasks with you. and you see the limitations of the product, you see where it's failing, but you also see where people are especially delighted. And what you see actually here in the picture is one of our labs. It's designed to be very comfortable and welcoming to our users, and at the same time, it has cameras to capture audio and video. So afterwards, we can actually go back into the data, analyze, and see exactly how we can improve the product. Usability studies are great, but they have their limitations. And I think the biggest limitation is that it's a very short period of time that your user is interacting with the product, and it's in a lab environment, so it's not the real life. So we went one step further and conducted diary studies. Diary studies, as the name already indicates, are studies where your user is going to keep a diary about their usage. So what did we do? We sent voice access home with the users on their personal devices installed, and they could use it in whichever context they wanted to. The only thing they had to do, as they had to promise us, was that they would report back about their experience. So you can do that over the phone, you can have them write emails, or just fill in a quick survey. And in the end of the study, they would come back into the office with us and give us the report, how they used the product, what they liked, what they didn't like. What we learned from that process is that for one, voice access really needs to be polished and be visually delightful. You've seen in the video the latest design that we have. We didn't start off on that. I have a few more examples on that in a minute for you. And the second thing, if you use it on the go, you need a really easy way to activate and deactivate it, because otherwise it's too much hassle for the user to actually dive into the software and then again, when you don't want it to listen, deactivate it. So let me show you these examples that I just mentioned. The first one that I would like to talk about is how we improve the contextual help. You see on the left-hand side the before, and on the right-hand side you see the after. So what is that? On the left-hand side, we see a long list of all the voice commands that we're offering. Everyone who's using or developing on voice-based software knows that the biggest challenge is how can you actually teach your user what they can say, and how can they remember that? So it is essential that we're offering a place where the user can go back and check again what they can say in order to get to a specific result. We thought it makes sense to just offer one long list, everything in one place. People will find their way. When we observed them in usability studies, we found that this is actually not the case. People got lost along the long list. They even forgot what they were looking for because they were so overwhelmed by all the stuff that we offer in there. And also the way we presented the information without any examples was not intuitive to understand for them. So what did we do? If you see on the right-hand side, the first screenshot, we had categories now. So we have basics and navigation, gestures, and text editing. And with those, the users deep dived into a smaller subset of commands, which you see then on the next screenshot within basics and navigation, that the user actually gets specific examples of the voice action that they can take. And by doing so, we actually had much better results that users were able to find what they were saying and also for remembering later on where to find that command again. The second example I'd like to show to you is our tutorial. Again, having a really good tutorial is crucial, especially if people have not used voice interactions before in order to navigate their interface. We wanted to make it as real as possible, so we took a screenshot of the interface and explained it to the users. What we didn't expect was that users would want to interact with this screenshot and wouldn't distinguish between a screenshot versus the real product. So we took that learning back and redesigned the experience, as you see it on the right-hand side, to be text explaining the functionality. So this is how to use the numbers, what Scott had demoed before. And we did have numbers now on the screen, but those are real, so you can interact with them. So the user is learning about it immediately, and they can apply the learning. And with that, we actually made really good progress. And now Jen is going to talk about usability testing and how you can use it for your very own application.
Thanks, Astrid. So in the few minutes remaining, we wanted to leave you with a quick starter guide of how to do your own usability studies, because we do find them very effective. And you don't need anything fancy to actually execute these. Usability testing is really useful to understand how people use your product and why, and that's the key point, is the why. Before you jump in and just bring somebody in and have them run through some tests, you want to have a plan and a strategy. First, starting with what are the key questions you want to answer with this research? Write these down, review them with your team, make sure everyone is on the same page. These are your research questions, and without solid research questions, the end result might not meet everybody's expectations. So based on these questions, then you'll identify tasks that will help you answer these questions. So for example, if a question was, are users able to onboard without any additional assistance? You would bring in the new user and have them start the app for the first time and maybe run through some of your key fundamental tasks and see if they can do it without asking for assistance from you, looking in the help, or online. Once you're happy with your study and your test questions and tasks, you want to think about who to bring in and actually conduct the study on. Now, you can certainly start with friends and family. Ideally, those people will actually be using your product or do use it. And we also highly recommend having a diverse set of participants as much as possible. And you can actually reach out to various organizations that lobby for accessibility needs, and they're more than willing to accommodate you and get some people to help run their study on. Now, when it comes to actually running it and figuring out where to run this, you don't need a fancy lab like we showed. You can just find a quiet, comfortable space, and you want to make sure that there's room in there for yourself, the participant, obviously. Ideally, you will have somebody to help take notes, and you'll have some video recording equipment, and also it's great to have a developer, a designer, somebody that's very close to the product there to observe as well. And there's been tons of books written on how to actually conduct usability studies effectively. They all kind of boil it down to these 4 key steps: asking the users to perform the test, and then taking a step back and just observing them, seeing what are they actually doing other than completing the task. Are they hovering in interesting spots? Are they using a keyboard? What keyboard shortcuts are they using? And that leads to the next point, which is digging into why. I noticed you were hovering over that button. Can you tell me why? What did you expect to happen? Or after they complete a task, did that meet your expectations? And this is the magic of usability studies, being able to actually understand the rationale and the meaning behind their behaviors. And then I think the most challenging part of this, especially if you are close to the product, is remaining neutral. You might have the urge to want to kind of defend or explain, well, we tried this, but we couldn't do this, so we tried this. This is not the time to do that. You're just there to listen, absorb the feedback, and move on. Oh, and then practice. Definitely practice at least once before bringing in real users. During the study, you want to ensure that you write down the most interesting findings right away. And then review those findings with your team after each participant. This will greatly help at the end, just kind of summarizing your findings. You want to, if you had the ability to actually videotape it, cut small video snippets to help support your findings. Again, not everybody will have been there with you observing the study, so when you're presenting your findings, you can show, look, this is how the users actually interacted with the app. And then one of the most critical pieces is it would be a real shame to do all of this work and have it just sit in a dock somewhere unused. You want to have somebody in charge, ready to drive the process to address these issues. You know, of course, it doesn't have to happen right then and there, but you want to be sure that somebody is taking the charge to prioritize and figure out what are bugs, what are feature requests, and when they will be addressed. So we have on our on the I/O app and our spaces a great link to give you more details on how to conduct usability studies if you're interested. And overall, we hope that you found that this brief overview of the research methodologies used for voice access inspiring, and hopefully you can bring it back to your team. And now back to Patrick.
All right. Thanks, Jen. Thank you, everyone, for attending. So, you know, as you can see, it's very important for us to hear from users with accessibility needs so that we can learn how to improve the platform, and for all of our developers to take into account Android development best practices so we can all make apps that are great for everyone who has different accessibility needs. So, if you'd like to try out Voice Access, it's in beta now. You can sign up for the beta at g.co/voiceaccess. Also listed on the screen here are some other talks we're doing that are accessibility related. Please attend those. They're all great. Come visit our sandbox. It's Access and Empathy. It's actually right over that way. And you can go there to do a demo of voice access. You can go see the demo of the Sesame head tracking, learn about many more things, and also attend our code lab. So thank you, everyone. Take care.
If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire data set like this. Now that we know how to work with the data set, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here, I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now, I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned simply by adding and removing two different groups of constraints and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to Coffee with a Googler. I'm Lawrence Moroney, and I'm here in New York City to meet with Roman Nurik. And Roman Nurik is one of our material design gurus here at Google. So material design, tell me, what's it all about?
Oh, Lawrence, what is material design? Yeah, it's kind of hard to explain. There's actually a video with a bunch of the original designers that created material design, and they get asked the same question, and they don't know how to answer it. It is a complex kind of thing. There's a lot of things going on. I guess at the most basic level, it's a design language. It's a design system. It covers visual, interaction, and motion design. I feel like most design.
Hey, hello everybody. We've got a full house. Thank you all for coming, and welcome to this talk about Project Tango and aerial learning. So my name is Wim Joersen, and I lead the Project Tango location team. So today, I will talk about aerial learning, which is one of the core technologies of Project Tango. And it's at the foundation of almost everything we're working on in my team. So it's something I really deeply care about. And it's exciting that today I could spend a whole session on aerial learning. And if you have no idea what aerial learning is, that's OK. We'll cover that in this talk. So let's get started with an overview of the key things that you will learn in this talk. So number one, by the end of this talk, you will be able to build an augmented reality application where you can put virtual objects in the world and they will stay in place. Like they will not drift away. So if you have built AR applications before, you know this is a really big deal. And I'll have a live demo where I'll show you how I place these objects and how they kind of stay in place in the environment. Number two, by the end of this session, you will know how to build multiplayer experiences where multiple Tango devices interact with each other. And this is obviously without any wiring, without any infrastructure in your environment. It just works with just your mobile device. And then finally, we'll talk about some future applications where you could imagine that you just never get lost anymore in large buildings. So I always like to start out with a quick poll to get a little more background about you. So by raise of hands, like how many of you have heard about Project Tango before today? All right, that's most people. How many people know about aerial learning? That's just a handful. And how many of you are here because it's just really hot outside? Just a few honest people. All right. So today, I really want you to come away with a really good understanding of what aerial learning is, like how it works, and also how you can use aerial learning to build like new applications and enable new user experiences. So I'll start out with a quick high-level overview of what Project Tango is, for those of you who are still new to Tango. So fundamentally, Tango is about enabling mobile devices to understand the world around them. So Tango uses computer vision for your device to understand the geometry of the world, but also to know its own position and orientation in that world. So in some sense, it turns your screen into an extension of the real world. Like your screen becomes this magic window into the real world. And if you look at the example here, so think about this device. If it understands what the world around it looks like, and it knows where it is in that world, it can start displaying some really interesting content about the world. Like you could imagine you can display directions on how to get from A to B, or you could display like virtual furniture in your house, and you can go look at it from all different angles to see how it would fit. Or you can imagine you can have a game that just plays out right in your living room. So Tango can enable a whole new range of applications that just simply weren't possible before. So let's look at the three main technologies of Project Tango. So there's motion tracking, depth perception, and aerial learning. And if you've attended talks about Tango before, you've probably heard a lot about those first two. And today, we'll mostly focus on the third one, on aerial learning. But let's do a quick overview for all three of them. So motion tracking is all about allowing your device to know like how it moves through the world. So as a developer, you can use motion tracking to know how your device moved relative to where it started. So if, for example, I start here and I move 1 meter, I can ask the motion tracking component, how far did you move relative to where you started? If I move back to my original place, I can ask motion tracking where I am, and it'll tell me that I'm back where I started. So motion tracking is all about allowing developers to ask the device how it's moving through space. Then depth perception. So every Tango-enabled device, or every Tango phone, has a special 3D camera. So with this 3D camera, the Tango device can sense the 3D geometry of the world around it. So if I point my device at the speaker desk here, it could sense kind of this geometry of the front of the desk. If I pointed at the back of the desk, it would sense the geometry of the back of the desk. So wherever I point it, it can sense the 3D geometry. And as a developer, you can query that 3D information in the form of 3D point clouds. So then the last core technology, area learning, this is what really gives your Tango device a memory. And it works in a very similar way to how people operate in the real world. So remember when you came into this dome or tent thing, probably in the back of your head, you started building up a model of like what this space looked like. Like you saw a speaker desk, there's 2 big screens, there's a lot of chairs, and you take that mental model and you store it in your memory. So imagine now if you would leave the room, let's say you go to the restroom, and when you come back later, you would quickly recognize that you're in the same space, because you recognize the desk and the screens and the chairs. So you would recognize that you're back in that same space. And Tango area learning works in a very similar way. So when you bring a Tango device into a new space, it will use its camera to look at the world and compute this mathematical description of what the world looks like. And it'll store that mathematical description in its memory. And when you then bring that same Tango device in the same room at a later time, it'll be able to compare what it sees with its camera to that mathematical description it's stored in memory. And when those two match up, it recognizes space and it knows exactly where it is in that space. So let's dive a little deeper into the details of how area learning works and even how Tango works under the hood. So Tango has this wide-angle camera that it uses to look at the world. So it's much like, in this example, when you're visiting a mall, your Tango device will look at a few key landmarks that it sees in the world. So for example, here on your left side, you see that vending machine. In front of you, there's some restrooms, and then there's another landmark like on top of the roof. So now what happens when you start moving in this environment, and you keep looking at those same landmarks, what happens is you see those landmarks all of a sudden in different places in your field of view. So if you, for example, look at that vending machine, initially it was on your left side, and as you move, at the end, the vending machine is almost right in front of you. And this is exactly how Tango motion tracking works. Like, Tango will look at all these landmarks in the world and see how they move as a device moves. And based on that motion, it can compute its own motion in space. So this is pure motion tracking. So this is still all without any memory. So in this example, if you're in the mall, if you would cover your eyes, spin around, and open your eyes again, you would have no idea where you are, because you didn't have any memory of that space. And the same, every time you start Tango motion tracking, it doesn't have any memory, so it always starts from scratch. So let's now think about, what if we add memory to this? So for a Tango device, it doesn't need to remember the entire image of what it sees. It only needs to remember those key landmarks that it's tracking. So in this case, it would look at a small square patch, like the little yellow squares, around each landmark to store kind of a mathematical description of what exactly that landmark looks like. So your Tango device doesn't care about the rest of the image, it just looks at those landmarks. So Tango will store 2 things in its memory. One is where it saw that landmark, and the second is that mathematical description of what that landmark looks like. And this is how Tango can remember a space. So let's jump to a live demo so you can actually see how this works under the hood. So I'll first just start up Tango motion tracking. So here, if you look at the left side of the screen, you get to see how Tango is looking at the world. You get to see yourself if you wanted to. And all those dots on the screen, those are the landmarks that Tango is seeing and that Tango is tracking. So instead of just looking at like 2 or 3 or 4 points in the world, Tango can look at 100 points at the same time. And as I move, Tango keeps track of how all those landmarks kind of move in the image. If you then look at the right-hand side of the screen, it's kind of a top-down view of where I am. So if I walk in a big circle here, you can see that motion tracking knows exactly that I walked in that circle and that I ended up back where I started. So this is motion tracking under the hood. So let's now jump to area learning. So initially, this looks very similar. You just have Tango looking out into the world. But now, Tango is actually building up a memory of what the space looks like. And once it has created a memory, so that has happened now, you see all these static yellow dots. Those are the landmarks that Tango has remembered. So I can go look at them from all different angles. They're literally physical points in the world that Tango has stored in his memory. And on the right-hand side, you see these lines coming out of the device. That is showing where Tango recognizes a landmark that's stored in his memory. So now we can do something really cool. So let's say I cover the cameras here. So my device has no idea where it is. And I'll just go hide it somewhere else. So now it should be completely lost. But if I point it back at the area that it learned, you can see all those landmarks popped back into place. So it actually remembered where it was based on that memory. So let me just do that one more time. So now it doesn't know where it is. And then you see jump, and all the yellow dots are back in place. So yeah, it's pretty cool, right? So this is really a view under the hood of how Tango operates for both motion tracking and for area learning. So now let's look a little bit at how we can use area learning. So you have a pretty good understanding of how it works, but let's see, what can it do for you? Like, what kind of new experiences can area learning enable? And let's first cover kind of an AR example. So let's say you want to put a virtual chair in your dining room. You want to see how it fits. The problem you're having here is that that chair will start drifting over time. And that is because if you just have motion tracking, you'll have very small errors that slowly accumulate over time. And if you walk around enough, your chair might look something like this. So it'll like slowly drift and drift and drift. So this is exactly the problem that we want to solve with area learning. So you want your chair to go back right there. So the way area learning can help here is it can build up a memory of where you placed that chair in the world. So it can remember where exactly you placed that chair. So even though if motion tracking slowly drifts, because Tango remembers where you place a chair, it can always correct it and put the chair right back in the right place. And I'll have a live demo of this coming up a little later. So it's actually pretty cool to see. So there's obviously a number of other AR-based examples. Like, let's say you're using the 3D sensor to start measuring the geometry of your world. If you have these like nice yellow annotations on your world, you want them to stay exactly in the right place. You don't want them to start drifting around. So this is, again, where area learning can help. And even if you have an example where your objects aren't static, like, for example, you have these monsters running around, you still do care that your virtual world and your real world stay aligned with each other. Because if you would start drifting, at some point your monsters would start running through the shelves, and you really want them to stay in the center aisle. So even here, with moving objects, you do care about that alignment. So again, area learning can help here. And now let's jump to the second kind of big use case. And that is multiplayer experiences. So the problem here is pretty obvious. You want to know where all the other players are in the world. And it would be awesome if you can do it without needing to put in cables or infrastructure in your environment. So how can area learning help here? So the key for multiplayer experiences is to have a memory of your space and to share that memory between all the devices. So when all your devices have the same memory, so here, this is the display of what your device could have memorized. If all your devices share that memory, they could all start recognizing where they are in that space. And in some sense, you turn the real world in your kind of way to tie all these Tango devices together. Like, you don't need any special infrastructure. Like, you're using your couch and your carpet and the poster on the wall, and they literally tie together this multiplayer experience. So let's look a little bit at how this actually turns out in the real world. Because the real world is always a little more messy. So I'll give a number of examples where Tango will have some challenges with area learning. And it will give you a bit of a better understanding of kind of where to best apply area learning. So if you look at these two images here, so the left side could be what your room usually looks like. And on the right, that's probably what you want your room to look like. And if you and me look at these images, we can kind of recognize that it's probably the same room. You see there's maybe the same shelves, there's some hangers that you recognize. So pretty sure, same place. But for a Tango device, those look like two completely different spaces. Because Tango has built up all these landmarks on top of the clothes and everywhere. If all the clothes move, all these landmarks have moved, and Tango would get confused. So it's kind of like, imagine you're walking around in San Francisco, and you're looking at some of the big skyscrapers to kind of keep yourself oriented. And then someone comes in and moves all the skyscrapers around. You'd be pretty lost. So this is really what happens to Tango when stuff in the environment moves a lot. So here's an example where things didn't move, but one image was taken in the day and one at night. So even though your landmarks are in the same place, they could actually look differently because of the lighting and because of shadows. And something that everyone that has played with cameras will probably recognize, if you have a dark room and a really bright window, you have troubles with your exposure. You either need to tune it on the window or on the room, but you cannot have it both ways. And this should be pretty obvious. If you have large crowds, they can make a space look very differently. And then another kind of extreme example, like Tango looks for visually interesting things in the world. And if your room is all white or like all one color, there's nothing visually interesting. There's no landmarks for Tango to recognize. So there will be a challenging space. And if you go outside, you can imagine a lot more different changes, seasons, weather, sunshine, shadows. So outside gets a little more challenging. So the question now is, how do you deal with all these challenges? And the key point here is time. Like, if you look at a lot of these changes that we talked about, those happen slowly over time. And some environments will change quickly, and some will change very slowly. Like, you could imagine a museum that has the same exhibition year-round, and maybe it has very constant lighting. There, your memory will be good for months and months at a time. And at the other extreme of the scale, you could imagine a subway station with lots of people running around. Maybe there's advertisements that change. So there, your memory would be valid for a lot shorter over time. So a really good strategy to deal with this is to build your applications relying on a short-term memory. So if you think about your AR application where you want to show virtual furniture in your house, maybe you want to look at it for like 20, 30 minutes. But then during those 30 minutes, your house is not going to change. So you're good there. Or if you want to play a multiplayer game in your living room, maybe you want to play for a couple of hours. But during that time, your living room is still going to be your living room. So if you rely on shorter-term memory, like area learning could be a very powerful and reliable tool. So let's get to the let's actually play this video. So this is a real-world example of area learning being used. So this video was recorded in the Zurich train station. And if you look at the video, you can see a lot of the challenges that we just talked about. There's some outdoors, there's some shadows that you see, there's people walking around. You can see the floors are kind of one color. But then still, aerial learning can actually work in this environment. So aerial learning can be pretty robust to a number of these changes. It's just the examples I showed were kind of extreme to kind of drive the point home. But you can see how it actually operates in the real world. And I'll go a little further in this video because there's actually something cool that maybe isn't always obvious. Because Tango fully works in 3D, you can actually go downstairs and it'll tell you in full 3 dimensions where you are in the world. So let's look a little bit at how to build an application with aerial learning. And again, I'll cover 2 examples. I'll have the AR example with drift correction, and I'll have the multiplayer example. So first one, so you want to use memory here to keep all your virtual objects exactly in the same place. So this is kind of where aerial learning will help you build this. And for this example, I will assume you already have an application that uses aerial learning. If you have an application that uses AR, and I'll tell you how to transition it to aerial learning. If you don't yet know how to build an AR application, Friday morning, Eitan Marder-Epson has a really interesting talk about how to build a full AR end-to-end example using Tango. So if you're interested in that, definitely go check out his talk. So, but here I will assume you have your application already, and we're going to port it to move to aerial learning. And the point of this slide is just to show you it is really easy. You need to change literally 2 lines of code. In the first highlighted line, you just tell Tango, please enable drift correction. In the second line, you will tell Tango, instead of measuring where your device is relative to where you started, measure it relative to this memory that will build up. With just those 2 lines, you can transition an app from regular AR to aerial learning AR. And let me show you a demo of how that works. So I'll show the same app first without aerial learning, and then with aerial learning. So this is a little AR app that allows me to place a really large cube on top of things. So, we are not using aerial learning, but the cube is pretty, it stays in place pretty reasonably well. But now if I'm a little more mean and I move around, you can see it's still more or less there. And if I do it a little more extreme, at some point, I will lose my cube, because it just doesn't remember anymore where it is. So let's now do the exact same thing, but with aerial learning enabled. So now in the background, Tango is actually building up that memory of what this speaker desk looks like. So now, let me place the cube back. So now we can do the same thing. I can shake the device. And if I look back, as soon as it recognizes the space, it can put the cube back exactly in the right place. I can do my previous example where I cover the camera, let the app get completely lost, and then when I open it back, as soon as it recognizes it, it can put the cube back in exactly the right place. So you can have applications where your virtual objects will stay where they are. Even if your session breaks, even if your user does something crazy, your virtual objects will stay in the same place. So let's jump to the next example. how do we build a multiplayer game? So this is a little bit more involved. It includes 3 different steps. So first, we will create a memory of, let's say, your living room. Then we will share that memory with all the devices, and then you play your game. So let's first think about how do you create that memory. So what that means, in your shared space, you want to build up literally this memory of what that space looks like. So how do you do that in code in Tango? Very simple. You tell Tango, start learning the area. And then when you're done, you say save. And then you have built up a memory of what that space looks like. So now, how to share that memory between your different devices. Again, pretty simple. Tango has an export and an import functionality. So you can export your memory from one device and import it on all the other devices. So once you have all your devices set up, you're ready to go play. So what area learning has done, or what that building up that memory has done, is created this one reference frame that can be used by all the different devices. Because that entire memory is all referenced from like one frame in your environment. So every single device in your multiplayer game can directly ask Tango, where am I relative to this memory? And if you have multiple devices using the same memory, they will all get their reference relative to that same reference frame. And this is how you run that in Tango code. You just tell Tango, please use this memory, and then you start asking Tango, where are you relative to this memory? So the code all looks pretty simple. So now I wanted to share a video, but I wanted to introduce the video a little, because I think it's easy to kind of underappreciate the awesomeness of the video. So the setting is exactly this picture here. So we have 3 players that have a Tango device in front of their face. So they are completely in a virtual world. They cannot see each other. And the video you're going to see is showing that virtual world of what one of the players is seeing. And one of the key things you should look out for, in that video, you will see a Tango device. And that, obviously, it's a virtual Tango device because it's a virtual world. But that device is actually exactly a match on a real device that's in the real world. And you'll see different players hand that device to each other. So think about it, how awesome that is. The players can only see their virtual world. So only if they know exactly where all the other players are, and they know exactly where that device is, only then can they do this comfortable handoff. So it's pretty amazing. So check it out. So this is filmed from the third person, so even the third person is moving around. And you see how the other 2 are just casually handing off the Tango device from one to the other. So this is only possible with registration between all those different components. So you have 2 players, you have the person filming it, and then the Tango device. You have 4 different devices tightly coordinated with each other. So pretty amazing. And then this is an example of kind of using VR. But if you want to try something like this for yourself, tomorrow night in the Project Tango After Hours, we have an AR multiplayer game set up. So you can go try it out. Also, if you want to just try Tango demos, the sandbox is there for the whole 3 days, so go test it out. We have a lot of cool stuff going on. Now that I'm advertising a number of things, there's 2 more Tango talks coming up. So tomorrow at 3 p.m., Johnny Lee will be talking about everything that's new within Tango, so definitely go check that out. And then on Friday morning, Eitan will be talking about how to build an AR application. So 2 more exciting talks coming up. So what's next for Tango and what's next for area learning? What's coming up? So I hope by seeing the demos, you've been wondering, like, when can I try this? And today I'm excited to announce that everything you've seen until now will be part of our release coming out next month. So yeah. So you'll be able to build these drift-free, drift-corrected AR experiences, and you'll be able to build multiplayer experiences. And this release is just the beginning for area learning. Like, the Tango team will keep improving and will keep building better and more robust algorithms. So this is just the very beginning. And as developers, you're getting a very early preview in what area learning can do. So this is the start of what will become a pretty exciting journey. So let's take a look at where this journey could take us next. Let's look a little bit at future applications. So here, imagine you're visiting a mall, and you're trying to figure out where you are in that mall. So you pop out your phone, you start up Google Maps, and then you get to see something like the image on the left. So you get a really nice floor plan of the mall, and then you see this big blue circle that tells you you're somewhere here, but we don't quite know exactly where. So now imagine what you could do with area learning. So imagine if your device could recognize exactly where it is in that mall. Like, you could pinpoint your location, and your experience could look a lot like the image on the right side, where you have an exact location, you even know exactly which direction you're facing. And if you take this one step further, if you combine that very accurate location with augmented reality, you can imagine that you can get really accurate directions on how to get from where you are to, let's say, your favorite store in the mall. All augmented in the real world. So I guess I hope this gives you some idea of where area learning can take us in the future, and that you realize we're just at the very beginning of what this technology can do. And then, obviously, we're not only at the very beginning of technologies like area learning, we're also at the very beginning of the Tango device ecosystem. So you've all seen the Yellowstone devices, which is our developer kit. There's thousands of those in the hands of developers out in the world. Now, Tango has partnered up with Lenovo. So Lenovo will be releasing the first consumer-facing Tango-enabled phone. And will be coming out later this year as a worldwide launch. So I hope, I want to end with this. I hope you realize this is actually a really great and amazing time to kind of be part of Tango and be a Tango developer. We have a lot of new technologies coming out. There's new devices coming out, and I think we really have this unique opportunity to redefine how people interact with their phones and even how phones interact with the world. So I'm pretty excited to see what we can build together. Cool. Thank you.
Including a useless feature like this in your training data can hurt your classifier's accuracy. That's because there's a chance they might appear useful purely by accident, especially if you have only a small amount of training data. You also want your features to be independent, and independent features give you different types of information. Imagine we already have a feature, height in inches, in our data set. Ask yourself, would it be helpful if we added another feature, like height in centimeters? No, because it's perfectly correlated with one we already have. It's good practice to remove highly correlated features from your training data. That's because a lot of classifiers aren't smart enough to realize that height in inches and centimeters are the same thing, so they might double count how important this feature is. Last, you want your features to be easy to understand. For a new example, imagine you want to predict how many days it will take to mail a letter between two different cities. The farther apart the cities are, the longer it will take. A great feature to use would be the distance between the cities in miles. A much worse pair of features to use would be the cities' locations given by their latitude and longitude. And here's why. I can look at the distance and make a good guess of how long it will take the letter to arrive. But learning the relationship between latitude, longitude, and time is much harder and would require many more examples in your training data. Now, there are techniques you can use to figure out exactly how useful your features are, and even what combinations of them are best, so you never have to leave it to chance. We'll get to those in a future episode. Coming up next time, we'll continue building our intuition for supervised learning. We'll show how different types of classifiers can be used to solve the same problem and dive a little bit deeper into how they work. Thanks very much for watching, and I'll see you then.
Hey gang, did you know you can send notifications to iOS devices using Google Cloud Messaging? Well, you can! Why would you ever want to do that? Maybe that's a better question. Let's find out the answer on this episode of Route 85. So, notifications. They're a great way for you to engage with your users. They let your customers know you have important new information for them, and when used responsibly, they can be a great way to keep users coming back to your app. But they're not super fun to implement. There's a lot of steps required to set up notifications in the first place. You need logic on both the client and the server, and if you're developing a cross-platform mobile app, and most of you are these days, you have to do this for Android and for iOS. And I'm not just talking about two sets of client logic either. It turns out sending notifications to iOS and Android devices requires different logic on the server too. See, if you've done any notifications work in the past, you're probably used to talking to APNS, that's the Apple Push Notification Service, to deliver notifications to iOS devices, and to GCM, that's Google Cloud Messaging, to deliver notifications to Android devices. And while sending notifications through these two services is similar, they each have slightly different features, use different protocols, accept different message payloads, and return different responses, all of which means that you got to keep track of what kind of device each of your users has and use two completely different code paths to send a notification. Or do you? Well, no. No, you don't. You see, one pretty great feature about Google Cloud Messaging that a lot of people don't know about is that GCM can relay to APNS any notifications you want to send to an iOS device. Now granted, you'll need to do some setup work like upload your APNS certificate to GCM and make sure your client sends its device token to the GCM service. But once you've done that, you can use GCM to send all of your notifications, no matter what platform your target device is, and GCM will deliver your notifications to the correct device using the appropriate service. What all this means is that you don't need to care about what device your user has anymore. You just have to write and maintain one code path, and as we all know, less code means less room for mistakes. But it's not just about using less code. By using GCM to handle your messaging for you, you can take advantage of some of the other nice features that GCM offers to developers, like topics. Topics allow your app to subscribe to notifications about any particular topic that you or your users want to. For example, let's say you've got a weather app and I, as a loyal weather fan, want to be notified whenever there's extreme weather happening in my zip code. Well, in the old way of doing this, you'd probably need to set up a database where you keep track of each one of your users and their devices and their zip codes and do this whole select users where blah 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 query, then loop through the results and send notifications to each device that you get back from this database query. But with topics, none of that's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water, if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic, and I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped.
Consider the simple URL. A few years ago, these were pretty straightforward. You clicked on one, and 9 times out of 10, you went to a web page. Then things changed. People started using their mobile devices for, well, everything. And these devices in turn started supporting the idea of deep links. Click on one of these deep links and it could take you not just anywhere on the web, but anywhere in an app as well. So you could use a deep link to point directly to a specific restaurant inside a reservation app, or give your new customers a personalized welcome based on the link that brought them to your app in the first place. At least, that's how they worked in theory. In practice, deep linking had issues. The same link wouldn't necessarily work on an iOS or Android device, and they behaved very differently, or didn't work at all, for users who didn't have your app installed. And for people who did install your app through a deep link, all of that great link info was typically lost during the installation process, leaving your personalized warm welcome out in the cold. So while deep links were great in theory, their uses were a little more limited in practice. Enter Firebase Dynamic Links. Firebase Dynamic Links are deep links that work the way you want them to. So you can create one single link that behaves one way on iOS, another on Android, and even a third on a desktop browser, and it will take you to a place that's appropriate to that platform. You can also set up dynamic links to change their behavior depending on whether or not your user has your app installed. For users who don't have your app installed, maybe you send them to your website, maybe you take them to the Play Store, or maybe you show them an interstitial describing the benefits of your app before you take them to the App Store for a smoother transition. More importantly, these links can survive the App Store installation process. So if your user installs your app when clicking on a dynamic link, all of that information is still available to you when your user opens up your app for the first time. So what does this mean? It means you can use dynamic links the way you've always wanted to use deep links. You can use them in marketing campaigns, from email to social media to banner ads to, heck, even QR codes. And in addition to install attribution tracking, you know, the kind that lets you know which campaigns are getting you the highest quality users, you can also give your users a customized first-time experience based on the campaign that brought them there. So if a user installs your music app because you showed them an ad for classical music, you can make sure your app takes them right to Chopin's latest hits when they first open it up. Dynamic links are great for sharing too. Your users can use them to share recipes, links to their favorite level in your game, or even coupon codes. In fact, dynamic links are the technology that powers Firebase Invites. And because dynamic links are a Firebase product, you can see their stats directly through the Firebase console. Find out how many people clicked on a link, or use Firebase Analytics to find out which of your users first opened your app through a particular link. To find out more about dynamic links, check out the documentation here and give them a try. And deep link away.
Bitcoin represents a way to transfer money anonymously and at almost no cost. And since it's an arbitrary currency with no nationality attached to it, you're free to exchange it with anyone in the world. What is money? Resources are limited, and they hold explicit value to people. Most resources are physical, and such needed to be traded in a physical form: diamonds, gold coins, chickens, or bikes. At some point, it becomes too difficult to physically transact those objects, and it's easier to agree, collectively, on the value of cash instead of gold. As we know today, this has many advantages. Credit cards and the modern banking basically gave us another abstraction layer on top of cash. There is a centralized system which defines who owns what resources. All of these trades are made virtually. This is the backbone of why Bitcoin is a valid idea. What is Bitcoin? Bitcoin is decentralized, anonymous, digital-only currency that recently received public attention. Bitcoin was originally developed in 2008. Like in any good mystery, someone using the alias Satoshi Nakamoto published a paper describing how Bitcoin could work. There's a very interesting story about this guy too. He must be very smart, but he never came forward to claim ownership or any part of the revenue. Just 1 year later, in 2009, Bitcoin started being traded. Where do they come from? Think about gold. You could buy it or mine it, and it's the same concept with Bitcoin. You do this by using your computer to hunt for 64-digit numbers. By having your computer repeatedly solve complex mathematical puzzles, you're competing with other miners to generate the number that the Bitcoin network is looking for. If your computer generates it first, you receive Bitcoins. The Bitcoin system is programmed to generate a fixed number of Bitcoins per unit of computing time. It is also self-sustaining, coded to prevent inflation, and encrypted to prevent anyone from disrupting its code. In the year 2140, the total number of Bitcoins in circulation will be capped at 21 million. So how much is a Bitcoin worth today? You'll need to Google it. Just type Bitcoin in US dollar, for example. You could also check it out at priv.com. Why are they anonymous? Bitcoin are pseudo-anonymous because they are built upon this centralized system. The Bitcoins themselves are anonymous. The wallets are not. Here is why. The base algorithm creates anonymity, but as the recent court cases show, if your Bitcoin wallet is identified and attached to a person, then someone can go through and track every transaction you've made. Bitcoins exist entirely on their own because there's no central infrastructure to shut down. You are identified by nothing more than your Bitcoin wallet address, a string of randomized letters and numbers. There are absolutely no identifying characteristic beyond that. For the paranoid dude, you can simply create a new wallet for each transaction. Here are some interesting startups that push the technology forward. We are still in the initial phase of Bitcoins, and there are many challenges and opportunities ahead. Exchanges, wallets, merchant services, security, and more. But this is something for another episode. Until next time, eat your vegetables and listen to your partners.
One word that's the bane of both the novice and expert programmer alike: threads. I'm Joanna Smith, and threading can be one of the greatest perf improvements you make, but it will also likely drive you crazy. Tom Sawyer illustrated threading perfectly a long time ago when he needed to paint that fence, because when you've got a large chunk of work to do and it's the same work over and over again, you call in some friends to get it done quickly. So for computations that are taking a long time, consider calling in reinforcements with threads. By allowing multiple threads of execution to operate on your dataset in parallel, you reduce the overall time required to complete the task. With Android, threading becomes especially important because the entire app runs on the main thread, which is also called the UI thread because it updates the UI. And when the UI stops responding, users stop using your app. So, when you want to perform some complex action in response to a button being pushed, for example, you'll want to move that off the main thread until it is finished so that the user can continue to interact with your app. Because there are few things worse than the dreaded application not responding dialog. However, integrating threads into your system is not for the faint of heart. You're going to have to rethink your entire approach to computational complexity and to your memory model in order to properly integrate threads. So, to avoid the rabbit hole, take advantage of the Android framework, which has been built to help you out. Careful thought and planning about your app's structure and flow will enable you to determine whether a thread should affect the UI or be entirely hidden. APIs like Async Task and Thread both help you manage the work and keep your app from hanging, but Async Task will also allow you to affect the UI, like when you want to display a progress dialog. So take a walk through your own app and see if there are places where it stops responding or gets exceptionally slow in response to a user action, and then move all of that extra work off the main thread. But, thoughtfully. Don't just change things willy-nilly. Because while threading may be intimidating, it shouldn't scare you. What is scary, though, is bad performance, which is why you should check out the rest of our Android Performance Patterns content and consider joining our G+ community for tips, tricks, and help. But most importantly, keep calm, profile your code, and always remember, perf matters.
and welcome to Supercharged. Now, this is a kind of TLDW. Last week, I did a live stream with Surma where we made some swipeable cards. Now, you probably recognize swipeable cards from things like Google Now, where you just kind of take a card and you dismiss it. And you can actually see what I've got on screen. This is what we ended up making. There you go, you see? Dismiss it and all that kind of good stuff. Now, the idea is, if you've not got an hour to watch that live stream back, although if you can, I would recommend it, and you can find the link to that below. If you can't, that's exactly what this is for. I want to step through the things that we learned, the things that we did, and just so you can get an insight into what actually went into it. So, before we actually get started, what I want to do is I want to step over to Theory Corner. Oh yeah, theory. Love theory. And what we can do in Theory Corner is discuss what we need to do. Join me. Welcome to Theory Corner. You can tell it's Theory Corner because there's some theory in a corner. Now, this is what we have. We've got the cards. You can tell it's a card because it says card. The cards have will, change, transform on it. The idea I have here is that we want each card to be transformed around the screen. And so we want to give each card its own layer. The compositor then can move those around with the help of the GPU. So long as we stick to transform, opacity, and we set will change, we should be good. So we move the card as you touch and swipe. But as you get across to this side, we have this marker of like 0.35. Now I picked that at random. You could pick a different number. 0.35. If you go past that point, we basically say, well, this card is being dismissed. So we slide it off to the side. The other thing that we're going to do is we're going to change the opacity. So the further you go across, the lower the opacity in both directions. So that works there. Okay. So we're going to put each card on its own layer, and shift it side to side, and fade it out. Let's go back to reality. What we're going to do here is we're going to step into the code so you can actually see bit by bit what we actually did. Here's the cards, and what we do first of all is we basically create an array from the cards that we've got in the document. So we'd have to have some kind of code that adds or removes those cards later on, but don't worry about that. We'll just get on with what we've got here. The next thing to notice is that I've got these named functions on start, on move, on end, and update. Now the first three are our input events, and I choose to do it this way. What I do is I take a copy of it by calling .bind on this, and that takes it from the prototype into the actual instance. But it does another thing for me as well. It means that it's bound to the instance so that in those functions, when I say this dot whatever, it's actually applying to the instance and not to the target's event. No, wait, the event's target. Oh, one of those two. So it also does something else for me. It means that I can do add event listener and remove event listener, and I can call it by name. I can say like this dot on start, for example. You can see that down here in the add event listener. So I do add event listener for touch start, touch move, touch end, mouse down, mouse move, and mouse up. All of them. Yay! And I can just basically say on start, on move, on end, and so on. And if I wanted to do the remove event listeners, I could do that, and that would just work out fine for me. So we've got our event listeners, and we have a bunch of variables here that are just sort of housekeeping, things that we need to keep a track on. The other thing I do is I start a request animation frame where I busily sort of kind of do an update. Now, if you're doing this in production, I would suggest you don't do it quite like this. I would start the request animation frame when the user starts interacting, and then when the animation's finished, I would stop doing the request animation frame loop. But for the case of this, just to keep things simple, I just start it right at the start, and I do a kind of busy loop through. So what do we actually do in the on start, on move, and on end event listeners? Wow, saying event listeners over and over and over and over and over again, that's not confusing for me. No. What do we do in those? Well, first, in the on start, the main thing is this. We basically take a marker for the start position of the interaction. Where does the user put their finger down on the screen? And then we get that with page X. The other thing we do is we take a copy of that for the current position, because as we move our finger, we're going to update the current position so we know where we started and where we currently are, and the difference is how far we want to transform the card. The other things that we do in this is we set the dragging card to say true, but as we discussed in Theory Corner, we set will change to transform. Now we can check that that actually works by going back to the code, bringing up DevTools, and in the rendering settings, we're going to show layer borders. Anything that's got its own layer is going to go orange around its border. You ready? So when I click, you can see that immediately the card gets its own layer, which is really cool. That means that we can transform and move it around cheaply, like we discussed over there in the Theory Corner. Here's what we've got in the on move. It's fairly straightforward. All we do is we take the current position of the input and we basically say that's the current X. Now inside the update, what we can do is we can say if they're dragging the card the screen X, which is basically the position of the card on the screen, is the current minus the start. That's basically how far they've moved. And we can apply the transform to account for that. Ta-da! Now, when the user stops interacting, we actually have to make a decision. If you remember over in Theory Corner, we said if the user is past that 0.35 marker, so it's a sort of a 0 to 1 range, 1 being the full distance of the card, 0 being not at all. If they go past 0.35, which is what I've chosen, but you could choose a different number, what we want to say is they are dismissing the card. And we do this by setting a target X, which we use later on in the update. And here we do screen X plus equals the target minus the current screen X over 4. What this is going to do is it's going to ease the card to that final position, which will either be the center or it'll be off to the side, depending on whether we've decided that they've gone past the point of dismissal or not. Then there's a little bit of tidy up that we do here. We basically normalize the drag distance and we use that to set the opacity so that the further across you get, the more fadey the card is. Ta-da! So far, so good. So the last little bit is what we do when you dismiss the card, because what we want to do is we want to slide all the other cards into place. And we do that with this animate other cards into position function. Let me show you what it looks like without that. I'll switch off the layer borders. Okay, here's what it looks like without that. You see all the other cards just snap into place, which you could do, but doesn't look quite so nice. So what we need to do is we need to transform them down quickly to where they moved from, which will be the height of the card plus the margin. And you can see that here. So we take every card that's after the current one, which is this, and we basically say translate yourself the height of a card plus 20 pixels, which is the margin. And again, this is hard coded, so you'd probably make this more dynamic in production. And then we basically go from that to no transform at all, and we use an easing of this cubic Bezier and a duration of 150 milliseconds. And all we need to do is just say card.animate with those settings. And then when you've finished, we say the animation's complete, at which point we can just reset the target and call it a day, and the animation's done. So with that switched on, you can see we get a nice smooth animation. So the only other thing to notice is when I'm dismissing the cards, you can see that the other ones get their own layer temporarily. This is because we're using element.animate and we're using a transform, and that means that those get temporarily promoted to their own layer. Cool. That means that it's also doing the same thing that we had over in Theory Corner. We're getting its own layer, which means it happens nice and performantly, and then when it's finished, the browser automatically demotes them back, and we're all good. So there you have it, that's swipeable cards. If you've got time, make sure you watch the live stream. There's loads in there. There's us finding and fixing bugs. There's just chatting about the general approach. All sorts of goodies in there. Hopefully you've enjoyed this little TLDW. Don't forget to subscribe to the channel, and I will catch you on the flip side.
Ladies and gentlemen, thank you for attending this session. We will be with you and starting this program in just a few moments. Thank you for your patience.
Hello. Thank you for taking your time on our sessions. How to build a smart Raspberry Pi bot with Cloud Vision and Speech API. I'm Kaz Sato. I'm a developer advocate for Google Cloud Platform. And
I'm Glenn Shires. I'm a software engineer on the Cloud Speech API.
Okay. I'd like to show us a demonstration video of the Cloud Vision bot at first. So let me share the video.
Cloud Vision provides powerful image analytics capabilities as easy-to-use APIs. It enables application developers to build the next generation of applications that can see and understand the content within the images. The service is built on powerful computer vision models that power several different Google services. The service enables developers to detect a broad set of entities within an image, from everyday objects to faces and product logos. The service is so easy to use. As one example of the use cases, you can have any Raspberry Pi robot like GoPiGo calling the Cloud Vision API directly. So the bot can send the images taken by its camera to the cloud and can get the analysis result in real time. It detects faces in the image along with the associated emotions. The Cloud Vision API is also able to detect entities within the image. Now, let's see how facial detection works. Cloud Vision detects faces on the picture and returns the positions of eyes, nose, and mouth. So, you can program the bot to follow the face. It also detects emotions such as joy, anger, surprise, and sorrow. So the bot can move towards smiley faces or avoid anger or surprised face. One of the very interesting features of Cloud Vision API is the entity detection. That means it detects any objects you like. Let's see how it works.
It's glasses. It's banana. It's automobile. It's money.
You see? Cloud Vision lets developers to take advantage of Google's latest machine learning technologies quite easily. Please go to cloud.google.com/vision to learn more.
So that was the demonstration video for Cloud Vision bot. So I'd like to discuss how to build this bot by using the Vision API in these sessions. But I'd like to start briefly discussing about the machine intelligence working behind the bot. Okay, thank you. So we are using technology called neural networks. So what is neural network? Neural network is a function that can learn from the training data set. So it's designed to mimic the behavior of neurons inside human brain by using the matrix operations. For example, if you want to do the image recognitions with neural networks, then you can convert your input image, such as the cat images, into a large vector, and then put that vector to the neural networks, where it does the massive amount of the matrix operations, such as the multiplications or additions between vectors and matrices. And then eventually you would have another large vector as an output, which represents the labels of the objects detected in an image, such as the cat or automobile or the human face. So let's take a look at another example how neural network works by using the dataset called double spiral. In this double spiral dataset, we have two groups of the data points. One is the orange group, then another is blue group. If you are a programmer and if you are asked to classify those data points, what kind of the program code you would write? Do you want to write many if statements or switch statements to, to classify the points, each location over the points by using the conditions and the thresholds? Do you want to write that? I don't want to write that kind of code. Instead, I would be using machine learning or neural networks so that I can let the computer try to find a way to solve this problem. So let's take a look at the demonstration. This is a demonstration called Playground, where you can just actually running the neural networks to solve these problems. Now you are seeing the computer is trying to find the optimal combination of the parameters inside neural networks to solve this problem. Actually, it's not working right, so let's try it again. Yeah, sometimes the machine learning fails, so you have to try multiple times. Now, here you go. The computer found a way to combine the parameters in an optimal way to do the classification with the double spiral data sets. So this is how neural networks works to solve your problem, rather than instructing the computers how to solve the problem by humans. Okay, go back to the slide. And you can apply these neural network technologies to solve the much more complex problems, such as recognizing a cat in an image or recognizing pedestrians walking around the street. You can do that, but you have to have many more hidden layers, the layers inside the input vector and output vector. So it takes a long time to finish training. That is called deep neural networks or deep learnings. But the largest problems right now for deep neural networks is the computational resource. It usually takes like a few days or a few weeks sometimes to finish your trainings with deep neural network. So that's the reason why Google has been researching on distributed training by using the Google Cloud, by using the GPUs or TPUs that can shorten the training times in order of 1/10 or 1/100th. And that is the reason why Google has been so successful on applying the deep neural network technologies to the many consumer services, such as the voice recognitions with Android devices, or the image recognitions with Google Photos, or the ranking in the Google search services. Now we have over 20 production services at Google that has been using the deep learning technologies underlying. And now we have started to externalize the power of the neural networks running on Google Cloud to external developers. The first product is called Cloud Vision API, and the second product is called Cloud Speech API. What is Cloud Vision API? Cloud Vision API is an image analysis service that provides the pre-trained model, so you don't have to train your own neural networks or machine learning model. Rather than that, you can just use the REST API, just sending your own images uploaded to the API. Then you will be receiving the analysis result in a JSON format in a few seconds. So you don't have to have any machine learning skill set or experience. And it's so inexpensive. It only costs $2.50 per 1,000 units or images, and it takes no charge to start trying out the API. So let's look at another demonstration for Cloud Vision API. Here I'm launching a demonstration called Cloud Vision Explorer, where we have imported over 80,000 images from Wikimedia Commons, uploaded on the Google Cloud storage, and applied the Vision API analysis already. And by using the result of the Vision API, we have done clustering analysis so that you are seeing the cluster of the images, such as sea cluster, or snow cluster, or estate or residential area cluster. And if you take a look at the cluster for cats, then you'll be seeing the many images that is classified as a cat, like this. If you put these images to the API will be sending back the results such as the cat or pet, or this must be a British short hair. All those results will be returned in a JSON format like this. But in these demonstrations, you can see them in the graphical UI. Also, if your image has a text inside it, then the API can convert the text inside the image to a string, like this. The 3 kangaroos crossing next 2 kilometers, you can get it as a string. Or if you have the faces in your images, then the API can detect the faces and locations of each face, and also the emotions of each face, such as joy, or sorrow, anger, or surprise. So you can easily find which face is smiling or not. If your image contains the very popular locations, then it can provide the name of the popular locations, such as Citi Field Stadium in New York City, with longitude and latitude. You can even put the markers on the Google Maps. Oh, sorry. You can even use the product logo detection features so that you can easily understand the image has the product logo or corporate logo. So that was the demonstrations of the Vision API. So let's take a look at how you can bring this machine intelligence into the Raspberry Pi bot. So CloudVision bot is based on a Raspberry Pi robot called GoPiGo, which is produced by Dexter Industries. So you can go to the Dexter's website to buy GoPiGo at around $200. And also you may want to buy a fisheye camera to capture the wider range of views surrounding the bot. And we have written a few hundreds of lines of Python code to capture the image by camera and send the image to the API. It's really easy to start getting started with the Vision API. You can just go to cloud.google.com/vision to getting started. You can try the quick start tutorial, and that should be finished within 30 minutes. This is a sample Python code to send your image data to the API. You have to convert the image binaries into the base64 text and embed that text into the content property of the request. And also you have to specify the types of the features you want to detect. In this case, it specifies the label detections as the features, so that you'll be receiving the labels as a result of the API analysis. And you can make the call to the API, then you'll be receiving the result JSON in a few seconds, so that you can easily dig into the JSON result to getting out the labels. If you specify face detection, then you'll be receiving the positions of the face and the landmarks, such as the bounding polyproperties, where you would have the X and Y positions. And also you will have the joy likelihood property, where you can find each face is smiling or not. So it's really easy to write a Python code to turn the bot into the direction of the face. And also, if it's smiling, then you can run the modules of the bot to follow the person. So let's take a look at the real demonstration of the Vision API bot. So I'm showing the console. So this is a user interface web console for the bot. So actually it's showing the Vision it is taking right now. Not sure it's working or not. Must be working. I hope it's working. Is it working? Not sure. Let me try. So if you put the flowers, it's not saying anything. So it looks like it's not working anymore. Maybe I can try fixing this stuff, so while doing that, maybe I can pass this stage to him.
Okay.
Yeah.
So you want me to jump into my slides?
Yeah.
Okay. Yeah, hi. So I'd also like to talk about the Cloud Speech API, which is actually a rather new API. It was released about a month and a half ago. And it joins a number of speech APIs that Google has had for quite some time, quite a number of years. You're probably familiar with the Android Speech API, which allows you to do speech to text and text to speech on Android devices, phones, tablets, autos, TV, etc. So that's in Java. That's a Java-based API. There's also the Web Speech API, which is in Chrome, which is a JavaScript-based API that allows you to do speech. And the Cloud Speech API is a new API that we've released that allows you to put this on any device. So whatever device or server you'd like to put speech into, we've made it very easy, and we support quite a number of languages. So we've made it very easy to integrate this into all sorts of different clients and servers. The Cloud Speech API is powered by Google's machine learning. So we've got a lot of experience with speech, and we've built that all into the API. So it's the same powerful engine that you have on Android, you have on Chrome, you now have available for whatever project you'd like to use it on. The models are pre-trained, so there's you do not have to learn machine learning to specifically use it. You can just get up and running immediately. And it supports over 80 languages and variants of languages. It's got real-time streaming. And so what real-time streaming means is that as I'm talking, the text is actually coming out while I'm talking. And what I'd like to do is give you a quick demo of that. So I'm sure you're familiar with this page, which has speech on it. Google search page. Web Speech API. What I'm doing here is pulling up a demonstration page for the Chrome Web Speech API. And make it a little bit bigger here. So what I'm going to do is, as I'm talking, I want you to notice that the words are coming out. And they're actually, first they'll be gray words because it's not quite sure. And then when it's very confident of the words, it turns them to black. So you can see as I'm speaking, the words are coming out and appearing on the screen. They turn black after it's very confident of what I said. And where's the presentation? Okay. So that's an example of the real-time streaming that's built in. And we have a limited preview right now for which you can sign up and join and start using the Cloud Speech API. Cloud Speech API is actually two different APIs. Or at least two versions of the same API is probably a better way to put it. There's a REST API that's a very, very simple way to use it. You can get started immediately. It's as simple as writing a curl command and some JSON. And then there's remote procedure calls, which gives you more power. Let me show you the REST API. And this is literally everything you need to know to do the REST API on one slide. You see on the left, there's a JSON request. And you can formulate that. You can make it more complicated if you want, add languages, add different types of ways you want to process it. You can even add context. A new thing we released is the fact that you can add new words to the vocabulary and new phrases. And so that's coming out this week. So you can make it as complicated as you want, but the simplest request would be exactly that, those couple lines of JSON with the content where you insert your audio file or your audio data. If you look at the bottom, there's a curl command. Kind of long, but basically all it's posting is a content type and posting to a URL. So it's taking that JSON, posting to the URL, and what you get back is that response that's on your right. And again, this is the simplest type of response. If all you want is one alternative, you don't want to see multiple alternatives and interim results, you'll get something that looks just like this. So as I said, there's actually two types of APIs. The other one is the remote procedure call API. And what that means is you can do everything by simply calling methods in your favorite language, in either Java or C++ or the 10 different languages that are supported. So you don't have to worry about the network. And it also supports the bidirectional streaming that I mentioned, so that as you're talking, you're getting the data back. So yeah, we support quite a number of languages for the remote procedure call. And this is actually open source. It's free and open source. So if there's a language that doesn't appear here, you can certainly build the source for that language and you actually use it on any language. It also uses HTTPS/2, which HTTP2 secure, which allows you to have some very robust bidirectional streaming. So what I'd like to do is demonstrate this. Go straight. Go straight. Go back. Stand still. Thank you. I like that command. Sit. Go to sleep. So I'm going to start that over, and we'll see. Let me move forward. So let me show you, while we're waiting for that to reboot, exactly what we're sending with the RPC calls. We're sending initial requests. Now, this is similar to the JSON that I showed in the last slide, but in here, we're actually using protobuffers to send this. So it's a very compact format. In other words, you're not sending extra bytes over the wire the way you are with JSON. So you send your request, you capture audio from the microphone, and in this case what we're doing is on a thread, we're reading a buffer full of audio and sending that buffer of audio. You will see what we're calling here is on next. So this request observer on next is code that's automatically supplied in any of 10 languages so that you can keep passing new buffers to it. And finally, you've got the response, which you can be running on a different thread because you're sending audio and receiving data at the same time. And again, there's an onNext command here that's provided automatically for you, which provides the data. And in this case, we're printing out the results of what we're receiving. Go forward. Spin left. Spin right. Go backwards. Do a dance. Go to sleep. Play dead. I like that one too. So there we are. So one thing I wanted to point out is it's responding very quickly, and that's because it's streaming the speech as I'm speaking. So it's not going to capture all the speech and then wait and then send a big chunk of data up. And as I'm speaking, it's going bidirectional, and so that's why I can do it so quickly. And my clicker is here. So what I'd like to do is, this is easier to show than to talk about, so let me show this. These are experimental features, I want to say. What I've showed you to date is what's available right now on the Cloud Speech API. These are experimental features that will be available soon. What time is it in Tokyo?
The time in Tokyo, Japan, is 9:29 a.m.
How do you say, when is the next train in French?
Quand part le prochain train?
Turn on the table lamp.
Not sure how to help with turn on the table lamp.
There we go. Go to sleep. So as you can see, I've demonstrated two different things in that demo. The first one is spoken answers. And what that's doing is as I'm asking questions, it's providing answers. And the second one is something that we've actually integrated with if this, then that, which is a way that you can integrate with all sorts of different devices. In this case, I've integrated with a light module controller so that you can actually set up your own triggers to do this. And this is exactly what I did. There's a web page that I went to, and I typed in what I wanted to say as triggers, voice triggers, various ways I wanted to say it, and what it's going to respond when I do say that. And what it does is it goes out and configures this, and now when I speak that phrase, or one of those phrases, it goes out and triggers whatever if action you would like to trigger. So you want to go back to yours?
Yeah, let me try the. I'm not sure if it's working or not. Maybe I can show the console. Yeah, let me try again with the bot. Oh, looks like it's working. Yeah, it looks like it's working.
It is reduced.
Yeah.
It is loud. It is currency. I'm smiling.
Yes.
How are you?
I'm fine. Thank you.
It is like hair. It is better.
Yes, it is.
It's goggles. Hello.
Not goggles.
It's bag. It's eyewear.
Yeah, it's eyewear. How about this? How about this? Yeah, if you keep smiling, then it tries to follows me. What is this? Can you see this? Oh. Napa. Ah! Thank you. So yeah, it works finally. So that, yeah, thank you. So that was our demonstration.
Okay, try to go back.
Yeah.
Okay. One thing I failed to mention with the if triggers, you can actually add parameters to those triggers. So you could add a number or a string parameter, and you could, for example, tell the robot to turn left a certain number of steps or degrees. So you can make the triggers actually quite interesting. So we have a number of resources that you should go out and take a look at. The Cloud Vision API and the Cloud Speech API. You are ready for sign up. And we also have, well, first of all, thank you, but we also have a number of other sessions that are coming up that you might be interested in. We have code labs that talk about machine learning. There's several machine learning presentations coming up. There's cloud office hours if you want to learn more about cloud and integrating with the cloud APIs. We have office hours throughout the next few days. And there's the sandbox. So thank you very much.
Thank you.
So
You are doing your usual session this year again. What's new in Android?
Yes, I am with Romain Guy and Dan Sandler.
And any surprises there that we can look forward to?
We're going to talk about Android and let me see. I'll try to build suspense for it, but no, I think you know generally what the kind of thing it's going to be in there.
All the new stuff.
Most of it. as much as we can fit in 45 minutes.
Tell me about the dinosaur.
Yeah, so have you used Chrome before? It's a web browser?
Yes, I've used Chrome before.
Have you ever been offline before?
Once, in 1998.
Nice.
Yeah.
So there's this fun little feature of Chrome where if you're offline, a little dinosaur comes up and there's actually a game that's in there and you start hitting the spacebar and it jumps around. And this year, we want to kill this dinosaur. We want to kill it.
But no, I totally know what you're saying, though. It's like every time I'm on my mobile device and the service cuts out and my experience stops because of it, it's a bummer.
Yeah, exactly.
And it doesn't have to.
It doesn't have to. And like, we always think of the offline use case of like, oh, what if we make it so when Timothy's on a plane, it still works? But in reality, with cell networks and the like, it's going up and down all the time. Yeah. So you don't want to just be in that second where you've got poor network capability, oh, it stops responding. Now you can take ownership of that.
I think, we're going to explore this in some detail again later, too. But the cool thing is it's got an NFC, and you can just tap your Android phone, and it keeps score for you.
So what would the score be right now if we'd...
You'd be winning. Decisively.
I'm British, so, table football is in my blood. Thanks for hanging out, man.
Hey, Dion, thanks for hanging out with me as well. It was really fun to explore behind the scenes at Google I/O 2016 with you.
Yeah, I hope the developers have a great time this year.
I think that they will.
Firebase makes authentication easy for end users and developers. Most applications need to know the identity of a user so they can provide a customized experience and keep their data secure. Firebase supports lots of different ways for your users to authenticate. If your users want to authenticate with their email address, you can build that for them. Firebase Auth has built-in functionality for third-party providers such as Facebook, Twitter, GitHub, and Google. It can also integrate with your existing account system if you have one. You're given the choice about how to present login to the user. You can build your own interface, or you can take advantage of our open source UI, which is fully customizable and incorporates years of Google's experience in building simple sign-in UX. No matter which one you use, once a user authenticates, 3 things happen. Information about the user is returned to the device via callbacks. This allows you to personalize your app's user experience for that specific user. The user information contains a unique ID which is guaranteed to be distinct across all providers, never changing for a specific authenticated user. This unique ID is used to identify your user and what parts of your backend system they're authorized to access. Firebase will also manage your user's session so that users will remain logged in after the browser or application restarts. And of course, it works on Android, iOS, and the web. That's Firebase Auth, allowing you to focus on your users and not the sign-in infrastructure to support them.
Hey there, Polycasters. Rob here. Welcome back to the show. As we've been working on Polymer, one of the probably biggest requests that comes in from developers is, when are we going to get a CDN for Polymer and for web components? Because it's kind of a pain in the butt every time you want to sort of like hack on an idea and you've got to use Bower and install a bunch of packages and wait for everything to download just so you can, play with stuff. So recently, the Polymer team has put out a brand new project, which is called PolyGit. It is a development CDN, which I'll talk about what that word means in just a second. But basically, it is a CDN that includes Polymer, all the Polymer elements, and the web components Polyfill. So if you want to hack around using something like JSBin and Polymer, you can totally do that. So if you go to the website polygit.org, you see that it bills itself as the Polymer Magic Server. And what it's actually doing under the hood is it's just using GitHub's RawGit CDN and extracting things from there and pulling them into, JSBin or wherever you want to use the CDN. So what I want to do here is just sort of like show you some examples of how you can use the CDN, how you can configure it to actually pull in your own packages as well, and basically just get hacking really quick. So over on jsbin.com, I've already set up this little sample bin. And the main thing to notice here is I'm using this base tag right here. And if you're not familiar with a base tag, in HTML, a base tag or a base element, it just allows you to set a URL And then any sort of subsequent URLs that you use, like for script tags or imports, they will all be relative to that base. So what we're saying here is we want the base URL to be polygit.org/components. This components directory is where Polymer and all the Polymer elements and all that good stuff lives. And from here on out, if we have any relative URLs, it'll just pull stuff from that directory. So I'm pulling in webcomponents.js. It's coming from that directory. I can import polymer.html. That'll also come from that directory. And so since we've got all this working off of our CDN, now we can actually sit here if we want. We can just create our own Polymer element right on JSBin. So I'm going to do that right out of DOM module here. I'll give it an ID of like xfoo. And I'll give it a template that just says like, hello from xfoo. And I'll also give it a little script tag. And inside of here, we will call the Polymer constructor. And we're going to say it is an xfoo element. And then the last thing we want to do is we want to just make sure that we use our xfoo tag somewhere in the page. And now you can see it showing up over there in our output. So this is really great if you're hanging out on the Polymer Slack channel, you run into a bug or some issue, and you're not quite sure how to explain it to folks. You can just go throw together a JSBin using Polygit and then share that JSBin with people so they can help you get unstuck. Now, I also mentioned that all the Polymer elements that we built are included in this CDN as well. So what you can also do if you find maybe a bug or an issue with something like paper tabs is you can go over here and you can just write an HTML import for paper tabs. So instead of just Polymer, I'll also pull in paper tabs. And then you can just start using that element in your page here. So I'll say I want a set of paper tabs. And then inside of here, I will write out maybe like 2 or 3 paper tabs. So we'll say this first tab is called foo. Second one is going to be called bar. And the last one will be baz. Foo, bar, baz. And there we go. Now over here in our output, I've got these 3 paper tabs working just as I was expecting. And if I had some issue, I could then take this. I could save this JSBin. I could go file a GitHub issue and point the engineer at this particular JSBin. And that way, it's going to help them triage that issue a lot faster and help them debug the actual problem that you're running into and hopefully get things fixed. Now, one of the coolest things about Polygit is that it is configurable. So not only does it pull in Polymer and the elements that team has created, but you can add your own GitHub repos to it as well. So if you go back to the polygit.org website, you scroll down here to the bottom, you can see that there is this sort of interesting configuration syntax. And it might look a little weird when you first see it. It took me a few times kind of working through it to understand what it's doing. But basically, what you want to do is when you are defining that base URL, you can configure it by saying, oh, I would also like to include this component. And this component might live like inside of some particular org. And maybe you want a particular version, like version 1.2.3. Or maybe you want a branch, right? Maybe you want like the master branch. That's some good handwriting right there. Or maybe you want just the latest tag. So if you include an asterisk, instead of pulling a particular version or a branch, it'll just give you whatever the latest tag happens to be. So to show you an example of that, I've again got a little JSBin here. And I'm just going to paste in a better URL here. So what I've done is I've configured Polygit to pull in 2 additional dependencies. The first is the markdown.js library, which is in the chjj org on GitHub. And I've told it to grab the latest tag. And I've also told it to pull in the mark-down element, which is something that I wrote myself. That lives in the Rob Dodson org on GitHub. And again, I've just told it to pull in the latest tag there. So now both of those are available in that CDN components directory. So I can just go ahead and write an HTML import to pull in the markdown element. And then over in my body, I can just start using it. So I can have a markdown tag. And we'll just drop in like a hello world for the header there. And we can see we're getting this sort of like huge H1 rendering over there in the output. So if you're working on an element or a project or something like that, and you want to show that to folks on JSBin, you can absolutely do that using Polygit as well. The one caveat there is that it has to have been published for at least 1 hour for it to be picked up by the Rawgit caching CDN. But once it's been published for about an hour, it should be available to you on Polygit. Now, the last thing I want to mention here is at the very beginning of the show, we said that this is a sort of development time CDN. And what I mean by that is it's not a CDN that you want to use for production. And the reason is because we're not doing any sort of like vulcanization or anything like that to optimize the elements that we're sending down. Instead, you're getting an individual dependency for everything that you import, which is actually pretty expensive in terms of HTTP requests. So it's great for development time. It's great for hacking on ideas. But when you get to the point where you want to launch something into production, you still want to use a package manager like Bower. You still want to use a process like Vulcanize to make sure you're sending down the absolute smallest payload possible. But if you just want to mess around with some ideas, it's perfect for that. So that about covers it for today. If you have any questions, please leave them for me down in the comments. Or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
Welcome back. We've covered a lot of ground already, so today I want to review and reinforce concepts. To do that, we'll explore two things. First, we'll code up a basic pipeline for supervised learning. I'll show you how multiple classifiers can solve the same problem. Next, we'll build up a little more intuition for what it means for an algorithm to learn something from data. Because that sounds kind of magical, but it's not. To kick things off, let's look at a common experiment you might want to do. Imagine you're building a spam classifier. That's just a function that labels an incoming email as spam or not spam. Now say you've already collected a dataset and you're ready to train a model. But before you put it into production, there's a question you need to answer first. How accurate will it be when you use it to classify emails that weren't in your training data? As best we can, we want to verify our models work well before we deploy them. And we can do an experiment to help us figure that out. One approach is to partition our dataset into two parts. We'll call these train and test. We'll use train to train our model and test to see how accurate it is on new data. That's a common pattern, so let's see how it looks in code. To kick things off, let's import a dataset into Scikit. We'll use Iris again because it's handily included. Now we already saw Iris in episode 2, but what we haven't seen before is that I'm calling the features X and the labels Y. Why is that? Well, that's because one way to think of a classifier is as a function. At a high level, you can think of X as the input and Y as the output. I'll talk more about that in the second half of this episode. After we import the dataset, the first thing we want to do is partition it into train and test. And to do that, we can import a handy utility, and it makes the syntax clear. We're taking our X's and our Y's, or our features and labels, and partitioning them into two sets. Xtrain and Ytrain are the features and labels for the training set, and Xtest and Ytest are the features and labels for the testing set. Here I'm just saying that I want half the data to be used for testing. So if we have 150 examples in Iris, 75 will be in train and 75 will be in test. Now we'll create our classifier. I'll use two different types here to show you how they accomplish the same task. Let's start with the decision tree we've already seen. Note there's only 2 lines of code that are classifier specific. Now let's train the classifier using our training data. At this point, it's ready to be used to classify data. And next we'll call the predict method and use it to classify our testing data. If you print out the predictions, you'll see there are a list of numbers. These correspond to the type of iris the classifier predicts for each row in the testing data. Now let's see how accurate our classifier was on the testing set. Recall that up top we have the true labels for the testing data. To calculate our accuracy, we can compare the predicted labels to the true labels and tally up the score. There's a convenience method in Scikit we can import to do that. Notice here our accuracy was over 90%. If you try this on your own, it might be a little bit different because of some randomness in how the trained test data is partitioned. Now here's something interesting. By replacing these 2 lines, we can use a different classifier to accomplish the same task. Instead of using a decision tree, we'll use one called k-nearest-neighbors. If we run our experiment, we'll see that the code works in exactly the same way. The accuracy may be different when you run it because this classifier works a little bit differently, and because of the randomness in the train test split. Likewise, if we wanted to use a more sophisticated classifier, we could just import it and change these 2 lines. Otherwise, our code is the same. The takeaway here is that while there are many different types of classifiers, at a high level, they have a similar interface. Now let's talk a little bit more about what it means to learn from data. Earlier I said we called the features x and the labels y because they were the input and output of a function. Now of course a function is something we already know from programming. Def classify, there's our function. As we already know in supervised learning, we don't want to write this ourselves. We want an algorithm to learn it from training data. So what does it mean to learn a function? Well, a function is just a mapping from input to output values. Here's a function you might have seen before, y equals mx plus b. That's the equation for a line, and there are two parameters, m, which gives the slope, and b, which gives the y-intercept. Given these parameters, of course, we can plot the function for different values of x. Now in supervised learning, our classify function might have some parameters as well, but the input x are the features for an example we want to classify, and the output y is a label, like spam or not spam, or a type of flower. So what could the body of the function look like? Well, that's the part we want to write algorithmically, or in other words, learn. The important thing to understand here is we're not starting from scratch and pulling the body of the function out of thin air. Instead, we start with a model, and you can think of a model as the prototype for or the rules that define the body of our function. Typically, a model has parameters that we can adjust with our training data, and here's a high-level example of how this process works. Let's look at a toy dataset and think about what kind of model we could use as a classifier. Pretend we're interested in distinguishing between red dots and green dots, some of which I've drawn here on a graph. To do that, we'll use just two features, the x and y coordinates of a dot. Now let's think about how we could classify this data. We want a function that considers a new dot it's never seen before and classifies it as red or green. In fact, there might be a lot of data we want to classify. Here I've drawn our testing examples in light green and light red. These are dots that weren't in our training data. The classifier has never seen them before, so how can it predict the right label? Well, imagine if we could somehow draw a line across the data, like this. Then we could say that dots to the left of the line are green, and dots to the right of the line are red. And this line can serve as our classifier. So how can we learn this line? Well, one way is to use the training data to adjust the parameters of a model. And let's say the model we use is a simple straight line like we saw before. That means we have two parameters to adjust, m and b, and by changing them, we can change where the line appears. So how could we learn the right parameters? Well, one idea is that we can iteratively adjust them using our training data. For example, we might start with a random line and use it to classify the first training example. If it gets it right, we don't need to change our line, so we move on to the next one. But on the other hand, if it gets it wrong, we could slightly adjust the parameters of our model to make it more accurate. The takeaway here is this. One way to think of learning is using training data to adjust the parameters of a model. Now here's something really special. It's called TensorFlow Playground. This is a beautiful example of a neural network you can run and experiment with right in your browser. Now this deserves its own episode for sure, but for now, go ahead and play with it. It's awesome. The playground comes with different data sets you can try out. Some are very simple. For example, we could use our line to classify this one. Some data sets are much more complex. This data set is especially hard, and see if you can build a network to classify it. Now you can think of a neural network as a more sophisticated type of classifier, like a decision tree or a simple line, but in principle the idea is similar. Okay, hope that was helpful. I just created a Twitter that you can follow to be notified of new episodes, and the next one should be out in a couple of weeks, depending on how much work I'm doing for Google I/O. Thanks as always for watching, and I'll see you next time.
So in a previous video, you learned that you can use GCM to send notifications through APNS to iOS devices. But to many developers, APNS is a bit of a black box. And come to think of it, so is GCM. Put them together and you've got a black rectangle, I guess. Well, personally, I find having a little background on how things work underneath the hood can help out a lot when stuff goes wrong. So let's shine a light on half of this big old rectangle on this episode of Route 85. So APNS is a service that sends notifications to iOS devices, whether the target app is in the foreground or in the background. So how does it work? Well, for starters, you need two important configuration bits to make this happen. First off, the device token. You can basically think of this as the address of the device you want to talk to, but one that's unique for your app. It's also not really the address of the device. You know how when rock stars check into a hotel, they use a fake name? Well, the device token is kind of like having that fake name. It lets the hotel manager know that, hey, it's cool for you to visit your rock star friend because you know the alias that they're checked in under. Is that Matt and Kim? Kind of looks like them, right? Yeah. So when your app gets permission from your user to receive notifications, iOS talks to APNS and requests a device token, basically a fake rockstar name, which is then given to your app. Now, if you were just building an iOS app using nothing but APNS, you'd need to pass this token back to your server somehow. We'll get into what GCM does at a later point. When your server passes this device token back to APNS, it's your way of both identifying the device you want to talk to, as well as proving to APNS that you're allowed to notify that device in the first place. The next bit you need is the APNS certificate. This basically allows your server to talk to APNS securely. And hang on, we've got some massively oversimplified explanations coming your way. One common way for two devices to talk to each other securely is to use public and private key encryption. Alice encrypts messages using Bob's public key, which only he can decode on his side using his private key, and then, vice versa. So let's imagine your server is Alice in this scenario. And if you want to talk back and forth to APNS, you're going to need your own private key.
We on? Hey, sorry for about the late start. There was some technical issues with the Chromecast. But thanks for coming out to listen to me talk about Vulkan. I know it's the first day of Google I/O, and hopefully all the excitement of the first day hasn't died down for you yet. It's the last talk slot of the day, so I'm sure people may be anxious to get out of here and start partying. But we are here to talk about Vulkan, and it's exciting all on its own. It's one of my favorite topics to talk about, and I've recently been asked to maybe tone down the Vulkan talk a little bit. So it may be good for you or bad for you. Let's find out. So let's go ahead and jump in. So Vulkan, lots of rules and no mercy. I've used this line a little bit in all of my Vulkan talks because I feel it captures the general spirit of how people feel about Vulkan right now. And it's a bit of a joke because Vulkan does bring a lot of good things with it, but it does have a lot of complications that hopefully this talk will help address some of it. So a little bit of introduction before we continue. As you can probably see from the program, my name is Hai. I am a creative technology lead on Google's Art Copy and Code team, and my role on that team is to explore different technologies to find out how we can leverage them for creative work. And some of the things that I explore are things like Vulkan. How do you leverage new graphics APIs for use in applications? And I started working with Vulkan about last December, a couple months before the February 16th launch. I implemented Cinder's Vulkan support on Android, Linux, and Windows, and then I subsequently ported all the demos to Vulkan. Cinder is a C++ creative coding framework. It runs on Android, iOS, Linux, Windows, OS X, and it's open source under the simplified BSD license. Currently, the primary render is OpenGL on the desktop and OpenGL on, OpenGL on mobile, and that's what it is now. Will it change in the future? Probably as Vulkan becomes more popular, with the exception of iOS and OS X, of course. And Cinder gets used in applications of all scales, anything from mobile to desktop to very large-scale installations that you might see in Times Square. Recently, Cinder has also been used in the clouds to generate content. Vulkan support became available in Cinder, as I mentioned earlier, on Vulkan's launch date. Since Cinder is a coding framework made to be used in very many general cases, the implementation is very much ongoing. So what this talk is not about, this is an advanced level talk, so it's not an introduction to Vulkan. It is not a tutorial on Vulkan, and it's not an in-depth examination on Vulkan. If you liked a really good read on, a quick read on Vulkan, RenderDoc has a really nice Vulkan in 30 minutes document. And if you need to see some tutorials on Vulkan, we have some tutorials available on the GitHub repo. And if we were all to sit here and do an in-depth examination of Vulkan, it would probably take about a month. But feel free, if you have any questions specifically about any of the topics, just stop me afterwards or find me afterwards, and I'd love to talk about them. So what this talk is about, the bulk of this talk is how to get up and going in Vulkan, in a kind of large way, not just writing sample code, but actually getting something to production. And so it assumes that you know about OpenGL ES, and assumes that you know a little bit about Vulkan or some other explicit graphics API like Metal or DirectX 12. And since Vulkan is definitely new, there are some sharp edges in Vulkan. And I try to point out the gotchas and why it's important to pay attention to things like device limits and the differences between desktop Vulkan and mobile Vulkan. And there's a short section on the things to consider if you're looking for performance in Vulkan. And again, these are kind of heavy topics, so if you find me say something that's weird and it's confusing, please find me afterwards, and I'll be more than happy to clarify them. All right, so to establish a baseline between OpenGL ES and Vulkan, so this question gets asked more than any other question when it comes to Vulkan. Is Vulkan faster than OpenGL/OpenGL ES? The short answer is yes, but not from a direct port. Vulkan is new, and if you want to leverage all the benefits of Vulkan, you have to change some of your code, if not a lot of your code, and definitely some of your thinking. Vulkan on mobile's feature set is comparable to that of OpenGL ES 3.1. However, it does go to include compute, geometry, and tessellation shader support. It is an explicit API. The developer is directly responsible or has direct control of almost every object in the rendering pipeline. The developer is also responsible for memory management. There are some new objects and concepts that do come with the API. There are also things that have similar names but function slightly differently. So one of the amazing features that Vulkan supports is validation layers. And if this is the first time you've heard of validation layers, they're essentially an API-level debugging error checking tool that lets you, figure out what's happening in the API. It's a very dramatic departure from GL get error. And the general rule of thumb for validation layers is to turn them on at the beginning of the project and leave them on until you shipped. The validation layers are cross-platform, which means the same validation code gets used on Android, Linux, and Windows. And one of the cool aspects of the validation is this. It's a function callback that you can supply to the validation layers that gets triggered every time a validation message gets triggered. And this is what the call signature looks like. And this is what a sample body looks like. As you can see, since it is, you can break it down into whatever granularity that you need based on the validation criteria. And if you're on a platform where you can't set breakpoints in the IDE, you can definitely set a breakpoint on any of these. And you can look in the call stack to see where the validation message was triggered. All right, so let's get a little bit deeper with Vulkan. Some friendly reminders before we start. And these are things that if you were getting a port from OpenGL ES to Vulkan, it's good to keep these in mind, even though they seem very trivial. The first thing is the coordinate systems. Vulkan's coordinate system is upper left origin. And this includes both rendering and texture coordinates. This one caught me off guard when I was first working with it. Everything I render appeared upside down and kind of backwards, and I thought I was doing something very wrong. Until I went and stared somebody down and asked them, why is it up or left? And there wasn't a clear answer, but it just is. And memory management basics. And in OpenGL, you didn't really have to handle a lot of allocations yourself, if any. In Vulkan, you have to kind of handle the majority of the allocations yourself. Buffers and images, definitely, and pools. Command pools are kind of handled for you, but descriptor pools are not. You still have to point out to Vulkan what you need. All right, so the first Vulkan topic, command buffers. So command buffers are one of those things in OpenGL that you hear a lot about, but you don't really have explicit control over. In Vulkan, that changes a lot. They are one of the primary things that you use to get pretty much anything done in Vulkan. And command buffers have to be allocated before their use. And command buffers are allocated from command pools. The command pools themselves must belong to a queue family, and we'll talk about queue families in just a minute. And when you're submitting command buffers have to be submitted to the same queue family as the command pool. And also, when you're submitting, you want to minimize the number of command buffers that you're using per frame. And when you hear this, don't try to use just one. If you try to use just one command buffer to do everything, you're going to end up starving the GPU. I also know that one through experience. It becomes quite difficult to try to fit everything to a single command buffer because you end up having to do a lot of code gymnastics. So in order to get the to ensure the best performance, you're going to want to use multiple command buffers, but minimize them as much as possible. All right, so some sharp edges on command buffers. One of the terms that gets tossed around with Vulkan a lot is multi-threading. And while there is a portion of the API that is implicitly thread safe, there are parts of the API that are not implicitly thread safe. You can't record to the same command buffer for multiple threads, but it's perfectly fine for you to record to multiple command buffers on multiple threads. And you can do something where you can record multiple command buffers on multiple threads, and then take all those command buffers and kick them over to a single submission thread and submit all the command buffers from there. That's perfectly fine. But if you're going to do recording for multiple threads, make sure that each one of the threads has access to its own command pool. And directly related to command buffers is queues. Queues is, again, one of those things that you hear a lot about in OpenGL, but you don't quite have control of. In Vulkan, again, it's very different. And it's important to understand queues from pretty much their moment of creation. And queues, implicitly, they have to belong to a queue family. And you know which queue family they belong to through the queue family index. And there are a limited number of queues. And you can find out how many queues a queue family supports by looking at VK queue family properties queue count. And we'll get to the queue family properties in just a second. But if you find yourself in a configuration where you want to do both graphics and compute, you want to prefer the combined queues over queues that support singular operations. So if you're looking to do graphics and compute, look for a queue family that supports both. And the primary reason you want to do this is at the beginning, or just at the initial point of your port, it just makes things easier to coordinate. Because if you start using multiple queues from multiple queues, you will have to do synchronization, and that can be a little bit of a headache. When you're working with queues, it's important that if you need to order the queue operations, do it through synchronization primitives and avoid using VK queue wait idle in performance critical code. There are times when there are legitimate cases to use VK queue wait idle, but all the times there isn't. And through personal experience, it's caused a lot of weird bubbles in the pipeline and kind of stalls that I didn't expect. And some sharp edges in queues. So not all queues are universal. The queue family dictates what functionality each queue supports. An Android specific notes on queue is that on Android, there's at least one queue that supports both graphics and compute. And you can present from any queue on Android. On the desktop, you kind of have to go looking around to see which queue supports presentation or not. And this almost goes without saying, but it's worth saying. You got to keep kind of precise counts on the queues. There are devices that only support one queue. So if a device supports one queue, it implicitly only has one queue family. So you want to check these properties before you start creating queues, because if you try to create more than one queue on a device that only supports one queue, you either get a hang or a crash. All right, pipelines, or pipeline state objects, as some people like to call them. Essentially, these are data structures that has properties that control pretty much everything that happens in the rendering process, and they're fixed function. So that means that once you compile them, you can't really change any of their properties. There's a caveat to that, since there are what are called dynamic properties, and the dynamic properties can be readjusted or can be adjusted via command buffer operations. And these include things like viewports, scissors, or blend constants. How many pipelines can you have? If you find yourself having hundreds or thousands of pipelines, that's actually perfectly fine. A typical application may have that many. And the reason, if you think about it for a moment, the different combinations of what you have in your rendering pipeline, in your rendering states, can easily create hundreds of permutations. But if you're getting to the point where it's over 10,000, you might want to figure out if you're having too many variations, or too much granularity in your variations. You can also cache pipelines, and the caching achieves two things. If you cache it at the driver level, it helps speed up the pipeline creation. You can also use a selection mechanism to where you can use a pre-made pipeline, and you can do this by looking at your pipeline properties and using a hashing function to select the pipeline. Excuse me. All right. So descriptor sets. And descriptor sets are one of my favorite areas in Vulkan, not because I have a fond affection for them, but I had to spend so much time with them. Descriptor sets are basically how the C++ side views gives you a perspective into how the resources the shader will need. And there's a few things that that may catch you off guard about descriptor sets, and we'll go over these things right now. The descriptor set binding numbers. So you can sparsely populate binding numbers on the descriptor sets, but keep the gaps small because unused binding numbers still take up memory. There also is a max binding number. It's not obvious, but if you try to assign a binding number of like 32,000, most GPUs won't support it, and the validation will call it out, and they'll tell you that your binding number is too big. There's also a limit on how many descriptor sets you can have bound at one time. And this gets reported to you by max bound descriptor sets. And right now, if you try to bind more descriptor sets than your device supports, you'll just get a crash. And if the thing with descriptor sets is that you will need to update them once they're created, so the shader will know what research you're looking at. So the general wisdom behind this is that you want to group descriptor sets by update frequency, and you only should update descriptor sets that have changed. Updating a descriptor set is fairly expensive. All right, some sharp edges on descriptor sets. Once you bind the descriptor sets, you can't do any updates to it until the next iteration of the command buffer, and then you should do that before binding. So here's the one really confusing thing that caught me off guard with binding descriptor sets. This function vkcmd bind descriptor sets, there's a parameter on there called first set. And it wasn't obvious from the spec what this meant, and so I thought it meant the index onto the p descriptor sets, which is another parameter. And to give you a better perspective, this is what it looks like. So at the bottom, you see the function signature. So this parameter actually refers to this field in your pipeline layout. And it's a little confusing because there's nothing that helps you figure this out. Somebody had to point this out to me. Essentially what this does is it aligns the descriptor set layout that you told the pipeline that you're going to use with the ones you're passing into the bind descriptor sets. So if you're running into a place where you're binding and you're getting a crash, or you're binding and getting a fairly unexpected behavior, just make sure that these two parameters align. All right, frame buffers. So frame buffers in Vulkan are slightly different than they are in OpenGLES. You can think of frame buffers in Vulkan as basically loosely attachment pools. Essentially, they hold an array of VK image views. And the relationship between frame buffers and render passes are fairly, it's fairly strict. Subpasses and render passes refer to attachments by integer index. There's no ordering requirements. And the attachments in frame buffers must have the same width and height. In the general case, you still have to resolve any multi-sample attachments to single sample before you use them in textures. Not much different from ES. All right, so render passes, as mentioned before, subpasses inside of render passes refer to frame buffers, attachments via integer index. Subpass dependencies. So when you start working with Vulkan, you'll see a data structure called subpass dependencies. And from a high-level perspective, what this data structure does is that it builds a dependency graph that you pass into Vulkan to tell Vulkan the order in which you want the subpasses to be processed. If you don't do this, some GPUs will process the subpasses as they see fit, and this may not be the order that you want them to be processed in. So make sure that when you're working with subpasses, be really clear and explicit about which order you want subpass to be processed in if you're going to use an earlier subpass in the results of an earlier subpass in the next subpass. And additionally on subpasses, if you need to use let's say you're on subpass 3 and you want to use something from subpass 0, you need to preserve that attachment. If you don't preserve the attachments, what will happen is they'll get destroyed when the subpass completes. And further on the subpasses, if you have subpasses that have multi-sample output and you want them to get automatically resolved to single sample, you can pass in images into the subpass data structure that does this, and they'll get resolved right as the subpass ends. So here's a diagram that describes the relationship between subpasses and render and frame buffers. You can see on the right, the frame buffers are basically just a list, and the render pass is composed of multiple subpasses. And there's actually no need for you to share one depth pass. You can have as many depth passes as you want, assuming that it's within the device limits. All right. Okay, so these are the next two topics, image layouts and pipeline barriers. I wish there was more time to get in depth with these. They're actually really they're pretty complicated topics. So I'll try to go over them as best as I can. The behavior of image layouts, they vary depending on GPU. Some GPUs require very specific image layout transitions, others won't. The one thing that you should know is that all Vulkan implementations will accept VK image layout general for pretty much all operations. You will take a performance hit if you do that, though. So if you want to ensure best performance, it's best to assume that all GPUs require specific image layouts and set your code to handle it in that way. Transitions between image layouts are both implicit and explicit. The image layouts can be transitioned explicitly using pipeline barriers. And image layouts, they can also be transitioned implicitly by render passes. And how that happens is there's a field inside the subpasses that asks you, like, what do you want this to be once you're done? You can also use the validation layers to correct any image layout errors that you may have. The validation layers are very fond of screaming at you every time there's an image layout error. So it's a good tool to have around. All right, pipeline barriers, if you've used them in OpenGL, they can be a little bit terse. There's two things I feel like you should know. The first one is that while they do look complex, they become kind of second nature with some practice. The other thing is there's a restriction on on pipeline barriers within render passes. And if you need to issue a pipeline barrier within a render pass, the subpass that you're going to issue the pipeline barrier in needs to have a dependency within itself. And you do that just by telling a subpass dependency the integer index of that subpass. And there's only two types of pipeline barriers that you can issue within a render pass, and that's VK memory barrier and VK image memory barrier. All right, so a little bit more advanced on the memory management. Since you're directly responsible for the allocation and usage of memory, just like regular old C, you need to do bounds checking. Make sure all your writes of buffers are bounds checked. If you write out of bounds, some drivers will let you get away with that, and what it does is it creates these incredibly difficult to track down bugs. It can create red herrings. It can create a situation where you overwrite something inside the vertex buffer, but it actually crashes when you try to do something with uniform buffer. So build some code around error checking to make sure that all your writes are in bounds. And flushing is something that's making its way back. After you do any host writes, make sure to flush. If you have command buffer operations that do a read, all the things that read depends on must be flushed before that read operation takes place. There is a slight caveat to the flushing. If you allocated memory with the VK memory property host coherent, you don't need a flush. All right, shaders. So SPIR-V is the official shading language of Vulkan, and it is a lower level language, so we're still using GLSL for a while. It must be compiled either online or offline to SPIR-V using either Shader-C or GLSlang. The same shader code can be used on both desktop and mobile. There is a big change to uniforms. Obviously, you have to use uniform buffers, but you can't have standalone uniforms anymore. Uniforms have to be within block variables, and they have to be within interface blocks, and the layout of these interface blocks are governed by the STD140 rules. And if you ever worked with STD140, it can be a little bit complicated. In Cinder, we use SPIR to cross to actually extract the offsets and size information from the SPIR-V directly. And if that's something that interests you, come talk to me afterwards, because it saves us a lot of headache. The other thing is that you should, whoever is working on your team on bindings or between the shaders and descriptor sets, spend some time understanding how they relate with the descriptor sets and the shaders. There's obviously a natural relationship, but it's really easy to make an error in one and kind of ignore that, it may create an error in the other, because you do have to keep them synchronized. All right, so performance considerations. So these are kind of self-evident things that we hopefully all hold to be true when we're talking about performance in graphics. Obviously, minimize hosted GPU transfers, especially on mobile, because that ends up taking a lot of power. Reduce round trips on any reads. That includes using compressed textures to speed things up. And in Vulkan, very specifically, try not to starve the GPU. Because when you starve the GPU, you can, the next round of you pushing data to the GPU can easily oversaturate it. And with respect to render loops, the best thing for you to do is to keep multiple frames in flight with Vulkan. I find this in Vulkan to actually be a lot easier to do than OpenGL. In OpenGL, at times I felt like I was at the mercy of the driver of what it was doing when I was trying to keep multiple frames in flight. With Vulkan, you can very explicitly do this because of how the nature of Vulkan. So if you have more than one frame in flight, say you have 2, then you obviously need to double buffer all your non-static resources. If you have 3, then you need to triple buffer your non-static resources, and so on and so forth. And this also includes things like your command buffer. And the command buffers are a good starting point if you need to figure out what resources are backing that particular frame. So you can start building a dependency graph from the command buffer back to the resource that you need. And so since you have multiple frames in flight, you'll probably need to handle the frame rate throttling yourself. This takes a little bit of work, and it requires both using the Vulkan sync primitives plus some CPU-side logic. And this is definitely an area where you do not want to use VKQ wait idle. I'm sorry, some of the Vulkan function names are really hard to say. And I know I'm screwing them up because they're a mouthful and they're really long, so I apologize for that. All right, so here's something that didn't exist in OpenGL, but I think it may be coming to OpenGL soon, is push constants. So if you're looking to do something really quick and there's not a whole lot of data that you need to pass between your code and the shader code, you can use push constants. And push constants, they don't require any buffers, they don't require any scripture setups. You can only push 120 bytes at a time. And the limitation on them is that you can only have one push constant for all shader stages per shader. And 120 bytes, you can fit about 2 4x4 matrices in there. So you kind of have to be a little bit clever of how you use them. And this sharp edge, the size and the offsets must be a multiple 4. It's not really a sharp edge. 4 is the default machine size for pretty much any GPU. So if your size and offset is not 4, something went wrong somewhere else horribly. But they are really quick and fast. And Cinder does have a sample of how to use this. And here's what they look like. It just looks like a uniform block, except where layout is, it has push constant. Excuse me. All right, so most projects will probably start on desktop and go to mobile. If you're not doing that, then you're really highly skilled. But for the rest of us, pretty much everything starts on desktop and then migrates to mobile. So Vulkan, the API is actually is crazy consistent. Cinder took 3 hours to port from the desktop to mobile. And the only thing that required changing was basically the WSI, or Windows Systems Integration, and the swap chain. And it pretty much ran. So I'm not saying that your code will take that short amount of time to port, but you can trust that the API is consistent. The only other area that's different is the extensions. So that's for the API. Now, the properties are a different story. So the properties for the features are very different from GPU to GPU. And those includes things like what image formats or buffer formats are host visible, and what depth/stencil formats are supported. So don't assume that 2 devices that may be similar in capabilities that their Vulkan implementations are equal. I made that assumption, and I found that to be completely not true. So, if you must, write a little tool that queries the properties of the devices, so it solidifies in your head what the devices are capable of. Since there's not a whole lot of Vulkan implementations right now, so you can kind of keep track of it that way. But it really helps. The other thing when you're porting is that have a strategy to find the best properties for that particular device. An example of this in Cinder is that we have a function called vkfindBest depth stencil format. And the reasoning for that is that on some of the devices, the best one was 32-bit float, while others only 16 and 24-bit integers were supported. Or at minimum, you can use properties that are known to work across all devices. All right. The other thing that you should be aware of is 3-channel format support is very limited, and this includes both image and buffer formats. So again, develop a tool that generates a device report on which formats are supported for the devices. And if you are relying on any data packing on your vertex or images, and you're using 3-channel formats right now, you may have to change the format that you're using. Which leads me to the next point is if you're also staging transfers between your source, your host data, and your GPU data, you may have to transform the data in the staging. An example of this is if let's say your host format is RGB. On some devices, RGB actually isn't a visible. RGB8 isn't a visible host format. So you may have to transform that to RGBA, copy it to the Vulkan memory as RGBA, and then do the conversion inside of Vulkan. The other way to work around this is to do a direct copy from buffer to image, using vkcmd copy buffer to image. There's a caveat to that, I'll get in just a second, but this essentially does a bit-for-bit copy from the buffer to the image, so you can basically just read your image into the buffer and then dump it into the image itself. The depth stencil copies are very specific in their behavior, and there's a good portion of the spec that talks about that. Compressed textures. So you should know, I mean, we kind of all know mostly these days what formats are supported. The thing not to do is don't assume that if it's supported in OpenGL ES for the device that is supported in Vulkan, it may not be. One nice thing about Android in this regard is that all Android Vulkan implementations will support ETC2, and some of them will support ATSE as well. And just for completion, the desktop support is essentially just the BC formats. They may have slightly more complicated names. Excuse me for 1 second. OK, so this is the last part of this, going from desktop to mobile. So again, not to harp on image layouts too much, but some GPUs will require very image layout transitions, and while others won't. It's just best to treat them as if they all do. And this is a really important point. I encourage, if you have any questions about this, please come talk to me. I can't say certain things on stage, but I can give you specific details if you want to know more about this. So pay attention to the device limits. This almost goes without saying, but again, it catches people more often than not, is that most of the vendors will go above and beyond in certain areas of the device limits and not others. And some device vendors will just kind of do the minimum. And it's not because one vendor is better than the other, it's just the implementation, right? But don't assume that the same classes on devices or the same class of devices have similar functionality. They may not. And if you run into any errors, especially with device limits, you can use a validation layer to track them down. All right, so that's about 41 slides of me talking without showing you any pictures. And let me fix that right now. So these, I know the word games is used in the title of the talk, and I'm not going to show you game engine demos, but I would like to show you render demos if that's OK. And the point of these demos is to give more credence to the fact that Vulkan is up and running, and you can do some pretty amazing things with it already. And so hopefully these examples are visually enticing enough. Can we go to the demos, please? OK, so this is a flocking simulation. It runs almost entirely on the GPU. It's a flock simulation of about I think about 4,000 fish. And essentially, the fish simulation is run on the GPU. And there's a shark that comes in every now and then, and it basically causes the fish to disperse. The The code for this is actually open source. It's a sample on Cinder. If you want to get it and mess with it, it's totally free. Whoops, stay awake. The original work was done by my friend Robert Hodgin, who was gracious enough to donate it as part of the Vulkan launch day efforts. And the next demo I want to show you is, it's also another demo by Robert. And essentially, this is, if you're familiar with NASA's capture of sunspots, this is what the images look like. So Robert wanted to create something that was a real-time version of the sunspots. So he just likes to create pretty pictures. But it turns out to be very beautiful. And the funny tidbit about this is that actually more than a few people have mistakenly thought this was the actual NASA capture. So this one, unfortunately, isn't open source. But if you would like the APK to either one of these, just come find me afterwards. I'll be more than happy to give it to you. Can we go back to the slides? Oh. All right. So to wrap things up, if you want to look at Cinder's Vulkan implementation, it's at github/cinder/cinder. We're on the Vulkan branch. If you want to connect with us about Vulkan, we really want to work with you to make Vulkan successful. Please visit this URL. And we have about 12 minutes left, and I'm more than happy to take any questions that you may have about Vulkan or Cinder. You're going to have to speak up. I won't be able to hear you. Yeah. Sorry.
Yes. Can you hear me?
Yes.
So my question is Android itself being powered by Vulkan?
Now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get a really good first paint, even in Safari and mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I
roll.
roll.
Pretty much. Impact. that's worth checking out.
That's the format of this
It's a
show,
mediocre
Eddie.
article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about AppShell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
And in that article, we also link out to tools that can help you get started with the application model really quickly that we're working on. So check that out.
Yeah, build a weather app.
So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with the username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left. Otherwise, go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice smooth looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those like few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, click here. And otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!